nuclear war.
Hey there, Hacker Frogs. It's me, the Shy Hat, and we're doing HackerFrogs AfterSchool today. We're doing HackerFrogs free hacking. We're hacking all the things. Hello and happy Friday to everybody.
Hack the planet! Hack the planet!
Hack the planet. Hack the planet. Okay, so we typically do a bunch of different topics on each one of these live streams. So these are the 4 topics we're going to be covering today. If you want to take a look at the schedule that we do over at HackerFrogs, this live stream here, you can find it over on our Reddit. We also have a Discord. If you're into Discord, Reddit, Discord, you'll find those in the chat. So today, the first thing we're going to do is we're going to do some puzzle games as our warm-up, because we like playing puzzle games because puzzle games give us a look into solving different, interacting with different types of systems and figuring out the best way to interact with those systems, which is what hackers do. And thank you, Waffler, for Hack the Planet. Yeah. All right, so that's the first topic. The second topic, we're going to be doing a hash cracking challenge. This one's going to be Brood It from TryHackMe instead of Crack the Hash, because I just figured out that Crack the Hash is incorporated into a third topic. So we're going to be doing a lot of hash cracking topics today, so 2 and 3. So the third topic is going to be HackerFrogs AfterSchool network hacking, and this is going to be our hash cracking topic. The fourth topic is going to be, we're going to be taking a look at a course from Scilab, not PicoCTF. I got that. It's a little typo. Stonk eating guy, thank you very, very much for the Hack the Planet. Okay, so without further ado, let's start into our first topic, which we're going to do for about 60 minutes. And while we're doing this, we can listen to some music. Go ahead and pull the music up. All right, and the puzzles we're doing are from Thinky Games. Okay, so I think the one we just finished is this one, number 31, so we're going to be moving on to puzzle number 32. Okay, and all right, let's do the intro over here. I did this puzzle, but it's not a very, very difficult puzzle, but we'll walk our way through it. So this is the puzzle over here. This is number 32. Okay, and Greg, tired of these antics, suggests to our hero to look for some clues in the garden. Big mistake, there's a shovel. So what this is it's something called a star battle puzzle. So this kind of puzzle is known as a star battle, specifically a 1-star battle. What we need to do is we need to place 1 star in each region, ensuring that there are no other stars in the same row or column, and that there are no 2 stars that are next to each other, including diagonally. So let's go Sudoku. I don't think we're going to be doing Sudoku for a little while, but we're going to be doing a few different other types of puzzles. So there can only be 1 star in each row, there can only be 1 star in each column, there can only be 1 star in each region, so each one of these demarcated areas inside of the black walls, only 1 in there. Stars cannot be next to each other vertically, horizontally, or diagonally. And you can click or tap a cell twice to cross it off. Use this to remind you where stars cannot go. Okay, so let's talk about how we're going to be solving this puzzle. So initially I had a hard time understanding how these puzzles worked, but by interacting with them a little bit more, they become easier to understand. So one major part of solving these types of puzzles is understanding how to eliminate cells. So let's take a look at this region for an example. So this is a two-cell region, which means that the star has to be in one of these 2 places. So whether it's in this region or this region, there are some shared cells that it blocks off. So in this case, if the star is in either one of these regions, it blocks off these cells over here. And because these cells are in this column, it also blocks off the rest of this column. So like that. But once again, we don't know where it is over here. We need to do some deduction. So that also leaves 2 cells available in this region, so this region here. So these are blocked off, which means that if there's a star in these cells, then these areas are blocked off. And it also means that these areas are blocked off, because this is the row where these stars are. Okay, and that also creates this 2-cell possibility, which means that these over here are shared by both of these stars or both of these cells. And it also means that, whoops. It also means that these cells are blocked off. And that leaves us with one region with only one possibility, which is this one over here. So if this star goes here, we can block off everything around it. And then we can also block off the column and the row where the star is. So we block these off, we block these off, and when we do that, we see that there's only one possible star available for this region here. So that blocks off these cells, and then we need to do some more deduction. So these 3 squares over here, so these 3 cells, if there's a star here, here, or here, in either one of these cases, this cell is going to be blocked off. And same thing with, well, not same thing. Okay, so how many do we have left here? So we've got, in this center region, we've only got 1, 2, 3 possibilities. And let's look for some other regions that got blocked off as well from the things that we put down. Oh, this is blocked off. So there's only 2 possibilities for this region. So if there's 2 possibilities for this center region, either here or here, they both block off this cell here, which means that we've got 2 possibilities for this square. And that means that if there's one in here, then this gets blocked off. And if this gets blocked off, then there's only one cell available for the middle region here, which blocks off this, and this, and this, and this, which means the very middle has to be this, which blocks off this and this. And that leaves... what does that leave? That leaves 1 for here, in this region, which blocks off this, which means that this region in the corner has to be this as the star, which blocks off this and this. And it also means that this has to be the star for this region, which blocks off this. And that means... oh, okay. And I forgot to block off this this particular row here. Okay, and that means that the last square has to go in the corner here. Okay, so that was a relatively simple puzzle. We'll move on to the next one. Okay, so let's see. Shocked by the destruction, Greg insists on moving elsewhere. Perhaps over on that nearby hill, a hill somewhere else to dig. So what is this next puzzle? So this next puzzle is what is called a nonogram. Hellresistor says, I got it. Awesome, Hellresistor. Yeah, it takes a little while, but you just have to do some deduction. So what kind of puzzle is this? This is a nonogram, a popular puzzle type also known as Picross. In this puzzle, we introduce asterisk clues, which allow anything to be placed in the corresponding row or column. Shade in the cells in the grid by following the number clues around the edges. So a number next to a row or column indicates how many shaded consecutive cells there are in that row or column. Okay? So if we've got a 2 and a 3, that means there has to be 2 shaded cells and then 3 shaded cells. Shaded cells form a single number clue. Shaded cells form a single number clue must not be separated from each other. So if we've got a 2, we can't separate these two. They have to be stuck together. And if there's a 3, they have to be stuck together. When a row or column has more than one number clue, that means there are multiple groups or shaded cells. These groups appear in the same order as the clues. Okay, so if we've got 2 and then 3, it's 2 and then 3. And in this case, if there's 1 and then 2 and then 1 along this column, it's 1 and then 2 and then 1. We have to leave a space in between, at least one space in between each one of these groups. The shaded cells can be in any position in the row or column as long as the group size and the order matches the hint. Multiple groups of shaded cells must not be connected to each other. So that means that if you've got a 1 and a 2, we can't connect the 1 and the 2 like this. This is not allowed. A row or column with an asterisk clue can have anything in it. So these asterisks over here, they're basically, they don't give us a clue, but we're supposed to get from the context of the other clues how we're supposed to fill these ones in. So these asterisk columns here. Okay, you can right-click on a cell or tap it twice on mobile to mark it. Use these marks to remind you where cells shouldn't be shaded. Alright, so I think this should be fairly straightforward. They've got difficulties for each one of these puzzles up at the top, and this is only a 1 difficulty puzzle. So we got 2 and 3, there's only one pattern we can follow for 2 and 3. It's 2, and then space, and then 3. And then this is 2 and 1 and 1. So we've got 2, and then space 1, and then space 1. Okay, and then we'll try taking a look at these columns now. So 2 and 1 and 1, there's only one pattern for that on this grid. 2 and then 1 and 1. And then we got 1 and then 3. 1 and then 3. We don't know where the 3 is going to go. And we don't know where the 1 is going to go, because the 1 doesn't necessarily have to go here. It could be here. And we could put like a 3 here and a 1 here, or the 1 could go here. So we don't know what the configuration is for this right now. But for this one, 2 and 1 and 1, there's only one pattern that fits. There's 2 and then space 1 and then space 1. And this one as well. 1 and 2 and 1. So that's 1 and then 2 and then 1. And this one as well, 2 and 3. So we got 2 and then we got 3. So we need to figure out this one right here, the 2 and the 1 and the 1 and the 3. I'm not exactly sure because there are multiple patterns that could fit. But oh no, we can't. So because this is 2 and 1 and 1, we can't put anything in these squares. And this is 2 and then 3, 2 and then 3. So this has to be the pattern here, because this is 2 and 3, which means that this has to be the 1, and the 3 has to go here, because we can't put 1 in here because it breaks this rule. 2 and 1 and 1. And then here, there's 2 and 1. So let's suppose we put 2 here. Let's suppose we put 1 here and then 2 here. And that turns out to be the solution. Okay, the hill is starting to look like Swiss cheese, but when our Thinky hero is on a mission, we'll move on to the next puzzle. Okay, and if you manage to finish that one, let us know in the chat. Thank you. So this is puzzle number 34. So never one to give up, our friend sets up an amateurish yet entirely serious archaeological excavation. So this is a... what is this? This is a minesweeper puzzle. Interesting. I don't think we've seen one in the dailies before. Okay, so this is a minesweeper puzzle, very similar to the game that you're familiar with, but where all of the numbers are visible right from the start. And don't worry, nothing will explode in this version. Mistakes are completely fine. Place pickaxes in the empty cells, ensuring that each number has as many pickaxes in its surrounding cells, including diagonally. Okay, so we're just filling in our pickaxes over here to create a pattern. Each number must have a corresponding number of pickaxes in its 8 surrounding cells. So this cell can only have 1 pickaxe beside it. So if we do more than 1, then this is illegal. Okay, so it looks like... So we can put down the pickaxes, and we can also mark off squares where it can't go. I'm very bad at Minesweeper, but I suppose it's a game that you can get better at. So let's go ahead and give it a go. So there's 4. There's 4 here, which means that this is full. There's also 4 here. This is 4, right? 1, 2, 3, 4. No, this is 5. So it can't be this. This fits here because we've got 4. 1, 2, 3, 4 surrounding this. And we need 1, 2, 3, 4 surrounding this. So 1, 2, 3, 4. Okay, and this has 4 now. So it can't be, so we can't put something here because we've already covered these ones. All right, let's continue. So this needs 1, 2, 3. Well, we don't know where this is supposed to go. So this is 2, this is 1, this is 1. So these might share this between the 2 of them, but I'm not completely sure. Hummamy Hummum. Hello, nice to see you here. What's up? And welcome to the YouTube chat. We're just playing a little Minesweeper logic game right now. If you want to play it yourself, you can do it over here. Okay, so let's see. So this is 1, 2, 3. This is 1, 2 here. So this needs 2, this needs 2, this needs 1. So if we go here, then this fulfills both of these and one of these. And then we can do 4, 3. Maybe like this. So this has 3 around it, and this is 2 around it, which means that we wouldn't be able to put any here and here. So if this is looking for 2, this is satisfied. This is satisfied, this one is satisfied. I mean, I guess the ones that we've already finished, we can put some X's in them. Okay, so we've satisfied all of these. This needs 3. And this needs 4. So we can put 1, 2, 3? No, that's too many. And in fact, we can't really... This cell needs 4. So 1, 2, 3... 1, 2, 3, 4. And then we can block this off. This needs 3. 1, 2, 3. And then this needs 3. It has 3. This needs 3. Maybe like 1, 2... These are for sure. These need to be here. Or maybe... I mean, I'm not really too sure. There must be like a logical way of doing this, but I'm not really completely sure how you would do it. Let us know in the comments if you know what the method is. If we get stuck, we can always look at the hints over here. So this is 1, 2, so this is satisfied. This is 3 now, which is not allowed. So we need to remove one of these and figure it out. Did you find the pattern? Is there... I guess there's a pattern that we're supposed to be drawing as well. I'm not too sure what the pattern is in this case. So this is 3 right now. This makes 4 for this one, so we need to get rid of one of the ones around here. 1, 2, 3, 4. I mean, this has to be in place because this needs exactly 4. So this number can get rid of... Every puzzle game has a pattern inside the rules. Yeah, you know what? Maybe I should learn. Maybe I should learn what the rules are. Okay, so we'll take a look at some of the hints. Are there any numbers that have exactly the right number of empty spaces around them? They must all be pickaxes. Those must all be pickaxes then. Alright, so if we start here, 4. 1, 2, 3, 4. And here, this also needs 4. 1, 2, 3, 4, but this has 5. This says 4, so these all must be pickaxes here. So as for the rest of them, we can't really be sure where the pickaxes are supposed to go. So this has 1, 2, 3, 4, 5 squares around it. No, 6. 1, 2, 3, 4, 5, 6. So this would be kind of a guess. But here, this is already fulfilled. 1, 2, 3, 4, which means that there can't be a pickaxe here. Okay, and... so as for the rest of them, we're not really too sure. So the next hint is, consider the 3 on the bottom row and how it interacts with the other 3 nearby. You might not be able to place all the pickaxes right away, but maybe some of them. The 3 on the bottom row. Okay, so we're taking a look at the 3 on the bottom row here. And how it interacts with the 3 nearby. So there's a 2 here, a 2 here, and a 3 here. So there's only going to be one pickaxe shared between these 2 squares, these 2 cells here. So maybe we can put 1 here, which satisfies the number 3, and it partially satisfies the 2 over here. So we can't put 1 here anymore because that'll overload this 3 over here. If we've got 2 and 2, this is 1. Maybe we can do this shared 1, which satisfies the 2. And then maybe we can put 1 here. And this satisfies the 2, this satisfies the 3, and this satisfies this 2. If we put 1 pickaxe right here, this satisfies all of these numbers, all these cells. Okay, let's take a look at it. You can't do that. Cipher Logic, hello, nice to see you. Nice to see you here. We can't do that. What is the, because of the 4 block? The 4 block? This one? Oh, this 4 block, right. So this 4 block currently has 1, 2. Ah, right, this interferes. Okay, so 1, 2. One, 2, 3, 4, so this is set. 1, 2. This one. So this has 3. This needs 3. This has 3 right now. Okay, let's see. Cipher Logic says, I would think of this as working right to left. Right to left. So we got this 3 over here, and it's got 2 already. Start with all the 4s, then they do the 3s, and then do the 2s. Then do the 3s, and then do the 2s. Okay, don't forget to mark cells with an X if you know they don't have a pickaxe. Okay, and the last... If you know the final pickaxe for a number must go in some set of cells, even if you don't know which one, any other empty cells around the number can be marked with an X. So we figured out, I think we figured out almost all of the 4s. So the 4s, this 4 is done, this 4 is done, this one's done, this one's done, and this one's done. Pablo Ramirez, nice to see you here. Is this a puzzle game? Trying, hello, nice to see you here. This is yeah, this is a puzzle game. You can try it out yourself. These are all free. I like to do stuff that's free. Loving the game, by the way. I'm glad you are. So this one's done. This 3 is not done. This 4 is done. This 4 is done. This 4 has 2. Then we need to figure out this 3. So there's not something here. I mean, are we sure? If it's free, it's for me. Yeah, yeah. This is what we like to hear. Okay, Cipher Logic says, I would like to think of it as working right to left. This is a fun one for sure. It's always interesting to witness how the brain works. Well, I mean, I'm actually not a super logical person. I have to learn the rules before I can solve problems. Okay, I'm just going to take a little sip of water because there's an ad going on Twitch right now. Just a sec. Okay, do you have any other games for improving logic? I mean, there's a lot of different puzzle games over at this site right here, these Thinky Dailies. Okay, Cipher Logic says that bottom rightmost 3 is the highest value right now. So the bottom right 3, this is the highest value. So this is, oh no, this is already, no, okay. We don't count this, we don't count this as a pickaxe. Okay, determining its axe unlocks future moves. So this only takes 1 more. We also need to fulfill this one above it. And this one has... So let's suppose we put this pickaxe here. I wish there was something for sure that we could use to what is the word? To block off other spaces. So we know this can't be a pickaxe. We can't put it here. The question is, are we putting it up here? Are we putting it here? Or are we putting it here? Now the 3 can take 2 axes. The 1, 2, 3, 4 pattern, shared block, I don't think, 1, 2, 3, 4 pattern, shared block, I don't think it can be put there. So we don't think it should be here. It's got 1, 2. It's like Minesweeper, but in reverse? Kind of, yeah. Kind of. So I really do like the the logic aspect of Minesweeper, but I'm not really good at Minesweeper. There's a bunch of rules for Minesweeper as well. Okay. In the middle of 3142, I don't think an X goes there. Cipher logic, let's see. So 3142. 3142. So you don't think something goes here. You don't think something goes here. So these ones are solved already. So if nothing goes here, then for this, it's 1, 2, it's 1, 2, 3, 4, like this. If we block off this and we block off this, that means that this is the only possibility. And Naimu, hello, nice to see you here. So that means this is solved. So if this is solved, then this is also solved. This needs a cup of coffee. Yeah, maybe. So this already has 1. This has 1. So if this is solved, this means that if it's got the requisite 3, that means that these are blocked off. Oh, you know what? That can't be possible because this needs 3. So the pickaxe can't go here. So this is not solved. So this is 1, 2, 3, but we can't have it here. So it might be here then, this for this final one for the 4. Okay, why are you putting axes where the numbers are? So we're putting axes where the numbers are to try to keep track of which ones we've solved already. So this one's solved because it's got there's only one possibility for this. So for this, there's only one possibility for this because we've filled in the 4 surrounding this one. This is not solved. This is 1, 2, 3, and then one of these 2 as a possibility. Because this is already solved, it blocks off this square. So we have to put it either here or here. I'm thinking that it has to be here. No, wait. I'm thinking that it has to be here because this... We can't put one here because this needs one of these to be shared between this other 3. Okay, what about the 1 and the 2 in the upper left corner? The 1 and the 2 in the upper left corner. I mean, we're not too sure what the possibilities are up here yet, so we're not gonna solve them yet. How Researcher says column 5. 1, 2, 3, 4, 5. Okay. So one of these has to be... So this has 1, 2, 3, 4. Between 4 and 3. Between 4 and 3, the pickaxe. Between 4 and 3, the pickaxe. So if we're talking about the puzzle, this is row 1, row 2, row 3, row 4, and this is column 1, column 2, column 3, column 4. You can also give coordinates like 4, 3, 4, 3, and talk about it like that. Otherwise, it's kind of hard to. Column 5, row 5. Column 5, 1, 2, 3, 4, 5, row 5. 2, 3, 4, 5. Okay, that's my tip. So there's a pickaxe. So you say that there's a pickaxe here. So if you say there's a pickaxe here, that means that there can't be a pickaxe here. But if there can't be a pickaxe here, then I can't fulfill this 3, because the 3 has 3 already. And we need, for this 3 that is next to it, we have to put 1 either here or here. Otherwise it can't have enough pickaxes. So I don't see how it could how it could possibly be there. So I think there should be a pickaxe here, and there's no pickaxe here. So if we do it like this, then this is done, this is done, this is done, and this is done, and this is done. And we can't have one, well, it's not that we can't have one here, we're not sure. So this is, and then we can put one here. I guess the next one we need to finish up is these other 3s. So this 3 is done. 3, 1, 2, 3. This 4 is 1, 2, 3, 4. This is done. This 3, well, this 1. So if we suppose that this 1 is finished now, then I think 6, 4, there's no axe. 6, 4. 2, 3, 4, 5, 6. 1, 2, 3, 4. You think there's no axe here. But it has to be here. Because this 4 requires 1, 2, 3, 4. There's no other possibility. Four, 6 by that measure. 4, 6. 1, 2, 3, 4. 2, 3, 4, 5, 6. So you think that there shouldn't be an axe here, or there should be? Row 6, column 4. Oh, row 6, column... Sorry. Row 6. 2, 3, 4, 5, 6, column 4. 2, 3, 4. Okay, you think that it shouldn't be here? I mean, if it shouldn't be here, then it has to be here. So now this has 3 pickaxes, and that means that this has to be blocked off. That means that this has 3 pickaxes, it's done. This has 2 pickaxes, it's done. This has 2 pickaxes, it's done. Okay, that makes more sense. That makes sense. So I think this region is all finished. So this 3, we've got 1, 2, and we need 1 more. This 3 is done. This 3 has 2. We need 2 here. Oh, this gets tough. That means that there can't be a pickaxe here. I don't know. Wait. Let's think about this. So this 3 is finished. This 4 is finished. This 3, 1, 2, 3. This is finished. This 4, 1, 2, 3, 4. This is finished. I mean, we could do it like this. 1, 2. You see a hamster? Okay. So the 3 is okay. This 3 is 1, 2, 3. This is okay. That finishes off these two. This one is done, and this, if the 3 is like this, 1, 2, 3, then this is done. Which means that this has to be able to share 1, and this has to be able to share 1. But that didn't finish the exercise, which means that something's wrong. Oh, there's 2 here. So this has 1, and this shares 1. This has 2. This has 1. Okay, column row, row 4. Column 1, row 4. 1, 2, 3, 4. And then column 1, row 1. Yeah. Is it because I've got these here? Yeah, okay. This was the pattern we were looking for. It's because it didn't like that we were keeping track of stuff with our pickaxes. Alright, we can move on to the next puzzle. So hopefully the next puzzle is a little easier than this one. Okay, it's a chest. Brute force might have found it, but it certainly won't get past this unusual lock. So what's the unusual lock here? Oh, it's a picture puzzle. Okay, so we're looking for a... That was a fun one. I'm glad you had fun. Okay, so 9, 2, 1, and then we've got... So we're looking for a 3-digit number. So what can we think of when we look at this when we look at these locks? So this is a 9. So triangle lock with 3 bands. So maybe 3 times 3. And this is maybe 4 times 2? No, it's not 4 times 2. Okay. Let's think about this. Nine by 3. So there are 2 variables in the locks. The shape of the lock and the number of red bands. In the hasp, I think the hasp is the name of the circular thing. So the shape of the lock, there are 2 shapes. There's a triangle shape, and I guess that could be the number 3. And there's also a square shape, and that is the number 4. Well, I mean, we're just kind of spitballing here because that's the number of sides. There's also the number of red bands in the hasp. There is... Somebody tell me if that's the correct number, the correct name for this part of the lock. So there's either 2 or 3, or 1. 1, 2, or 3 bands. Three and 4 the shape. Also the gold hasps. I'm not too sure. Let me look it up really quick. What is the round part of a key lock called? Key lock is probably the wrong parts of the door defined. Okay, trim, faceplate. Let's just look it up. What is a lock hasp? Triangular metal plate. Oh, okay, okay. So that's not what we're talking about either. What kind of lock is it called? Padlock. These are padlocks, right? Parts of a padlock. This is the shackle. Okay. So this is the shackle or shank. This is the locking bar. So this is... Okay, so we're talking about the shackle. So 1, 2, or 3 bands, and then the shape of the lock. Triangle, square, and then the number of bands. 1, 2, or 3 bands. And let's go back to the puzzle. So this is a 9. Why is this a 9? So we think this might be a 9 because it's 3 times 3. This is 3 times 3. And in this case, it's 4. Maybe the triangle means multiply, and the square means subtract. Or subtract from 4? Subtract from 4, multiply with 3? It doesn't work here, because there's 3. Multiply with 3. That doesn't work. Oh, yeah, there's also locked and unlocked. Yeah, that's true. There are 2 other possibilities here. Okay, the shackle can also have 2 states. Locked or unlocked. Okay, or it's like 4 and 2 and 3 and 3. Okay, so this might be 9 because if it's locked you multiply, and if you unlock you subtract. But that doesn't make sense either. If it's unlocked you subtract, then it's 3 minus 3, which is 0. I'm just glad you don't use Vi. I mean, I just use the easiest thing I can use. Locked is I and unlocked is something. 3 and 3. So maybe unlocked means something else. So this has to come out to 2. We think that if it's like 4 minus, do something to, according to the number of bands, red bands. So maybe 3 unlocked means... So we need to figure out what the difference is between the triangle lock with 3 bands that is locked, and the triangle band with 3 the triangle band with 3 bands. The triangle lock with 3 bands that is unlocked. Because this is 9, and if it's unlocked, suddenly it's 1. So what's the logic here? Yeah, 3 red bands. 3 red bands, triangle and closed, and 3 red bands, triangle and open. Unlock might mean subtract or divide. Yeah, it could. But how do we do 3? So Haku, hello, nice to see you here. And you're saying that 4 and 2 equals 2? 4 divided by 2. So 4, so this is division. So it's 4 divided by 2 equals 2. I mean, it makes sense for this middle lock, but doesn't make sense for this lock on the right-hand side. 3 angles divided by 3 lines on the shackle. Okay, so 3 divided by 3, and this is 4 divided by 2. And this is 3 times 3 to get 9. I mean, this makes sense. So this is 3, and because it's open, we divide. So 3 divided by 3 is 1. 4, because this is a square lock, 4 divided by 2, which is the number of bands, and we divide because the lock is open, we get 2. So this logic fits. We just need to figure out what these are now. So this is 4 times 2, because it's closed. 4 times 2 is 8. So the number of bands is one number. The sides of the lock, 3 or 4, is the other number. And the state of the lock, open means multiply, and closed means divide. So if we have a square lock, which is 4, and 2 bands, if we have a square lock and it is open, which means we divide, 3, 4, or 5. 3, 4, or 5, is there like a octagonal lock as well? And there are 2 bands. The operation is 4, or the equation, I guess we can call it. Equation is 4 divided by 2. 4 divided by 2 equals 2. Okay, so I guess the only thing we need to do is take a look at the picture. So it is square, closed, 2. Square equals 4. Closed equals divide, and 2 equals 2. And that means it is 4 divided by 2 equals... No, wait, it's closed, which means we multiply. Closed equals multiply. So 4 times 2 is 8. Okay, so that's the first one. The second one is, oh, we've got an, what is this, a hex? This is hex, right? So hex equals 6. 6 open 3. Open equals division. 3 equals 3, so this is 6 divided by 3, and that's 2. So that's 8, 2, and the last one is octagon. No, sorry, pentagon. 5 closed 1. 5 times 1. Sorry, let's record this. So this is pent equals 5. This is closed equals multiply, and 1 equals 1. So this is 5 times 1 equals 5. So I mean, if this is what is happening, it's 8, 2, 5. Let's go back and 8, 2, 5, submit, and that's it. Okay, great. We did that. We got 7 minutes left. I wonder if we can do one more. Okay, a few gold coins. Who needs those? More importantly, a mysterious photo. Wait, what is that? Okay, the next thing is This is a slither link puzzle, so these are usually pretty easy to do. Uh-oh. This is a slither link path puzzle, a variation on the popular puzzle type slither link. In this version, rather than an enclosed loop, you draw a path from the start point to the end point. Trace a path from the entrance to the exit, ensuring that each number is surrounded by the indicated number of lines. Keep in mind that the path must form a single line from the start point to the end point. The numbers indicate how many sides of that cell must have a path going along them. Empty cells may be surrounded by any number of lines. Okay. The path should not branch nor cross itself. Okay, so I guess this is what we're going to do. I think the most useful thing we can do in this puzzle is we can cross off places where we cannot have a path. So basically we need to make a path that goes from the beginning to the end, but we need it to cross... We need to go next to each one of these cells a number of times. So this means it has to have 3 lines surrounding it. And we just need to make sure we've got the correct logic path. So the easiest thing we can do first is we can just define where we can't have our path around these zeros, and then we need to pursue it from there. So which way are we likely going? Are we going left first, or are we going right first? Because it kind of... I think we're going left first. So we would go like this. I think we're going like this. So this fulfills 3. We can't have one here. And then we go straight past this 1. So this fulfills the 1. And then we go up here. And we need to pass by like this. Oh, but we could go this way. If we're going that way, then we go like this. So we go up here, do 3, do 1, cross by, do 1. And then we need to get past here without... We can pass by like this. So this fulfills 3. Then we go up, and we can go like that for 3, and then go up, pass by, and that finishes the puzzle. Alright, that wasn't nearly as difficult as I thought it was going to be. And that was a that was a 3 difficulty puzzle. I'm not too sure why. Okay, let's, how much time do we have left? We got 3 minutes. I wonder if we can finish the next one in 3 minutes. Is there a next puzzle? Should be 37. Okay, so what is this one? This one is nonogram again. Alright, we'll try to solve this nonogram as fast as we can. We just need to make sure to follow all the rules. So this is 6 and 1. 6 and 1 only has 1 pattern, I think. 3. So 1, 2, 3, 4, 5, 6, and then 1. So 6 and 1. We also have another 6 and 1, which is going to look like this. And then we got 2 and 5. 2 and 5 also has only 1 possible pattern, so it's 2, and then 5. and then 1 and 5. This one is 5. So if this is 5, then this is the only way we can do this. Cross these off. We'll also cross these off. This is 1 and then 2 and then 1. 1, then 2 and then 1. This is 1 and then 5 and then 3. Because the 1 is already here, we know that these can't be... These are not possibilities. And let's see. So 1 and then 2 and then 1. 1 and then 2. We don't know where the other one is in this row. We got 1 and then 1 and then 2. This one is 7. Okay, so 7 means that it has to be all the way across. 1, 2, 3, 4, 5, 6. Oh, there's 8. Never mind. No, wait. No. It has to be this. 7 all the way across. 1, 2, 3, 4, 5, 6, 7. Which means we block that one off. The 5 row can be filled in. So 5, 1, 2, 3, 4, 5. Yeah, this one is also 5. And this is also 5. So that it's got to look like this. What else? We got 2 and then 2. So we already have 2 and 2 like this. So we can block these off. SysOS says, I decided some sleep was better than no sleep between streams. No, definitely go ahead and get some sleep, SysOS Master, yeah. Alright, so let's see if we can solve this before we move on to the next puzzle. Sorry, to the next part of the stream. 1 and then 5. 1 and then 5. 1, 2, 3, 4, 5, which means we block this off. 1 and then 3, so this is already fulfilled. So we can block this off. 2 and then 5, this is done. 6 and then 1, this is finished. So we got 1 and then 1 and then 2. So this is the 1, this is the 1. We don't know where the 2 is here yet. Got some sleep? That's awesome. That's awesome to hear. So this is finished. 1, 2, 3, 4, 5, which means that we can block these off. 1 and then 2. We don't know this yet. We only have 1 here. So the 1 is here, which means we can block these off. You do know where that 2 is. Oh, we know where the 2 is now, yeah. Now that we've isolated it. Okay, so this is done. This is 1 and then 1. This is 1 and then 1 and then 2. 1, 1, so we know the 2 is over here. Okay, and then we got 3 and 1, so this is the 3 and 1. Oh, looks like we finished it. Okay, awesome. That was pretty fun. We got to do some deduction, and yeah, that was pretty fun. Okay, if you want to try this yourself, then this is it over here. So what we're going to do now is we're going to move on into the second part of today's stream. We're going to be doing some hash cracking, some password cracking exercises over at TryHackMe. So TryHackMe is a room called Brute, and Brute is a good room for learning about brute forcing, because we do a lot of brute forcing in this room. So if you don't have an account over at TryHackMe, you can make one over here. So for this exercise, because we're also going to be using TryHackMe for the next exercise after this, we're going to be accessing this using the VPN key. So this is going to be my platform access over here. So for this exercise, we're assuming that you have access to some sort of cybersecurity distribution of Linux, like Kali Linux or Parrot OS or BlackArch or something else. I'm going to move into my VPN keys directory, and then I'm going to get my key for TryHackMe. I think this is my key for TryHackMe right now. We'll use OpenVPN to access their network. Okay, and you know what? I need to change my overlays. So topic 2 is here. And topic 3 is on deck. Oh, why is this not visible? Okay, so we're doing the TryHackMe challenge for crack the hash. This is actually not crack the hash. This is brood it. Okay, and now that we have access, well, we can always test for access after we connect via OpenVPN by using the IP command. So if we use the IP command and we've got a ton interface and we've got an IP address, we're probably connected to the network or the private network. Okay, so over at brood it, after you've joined the room, let me go ahead and reset my progress for this room. And I'll leave the room, and then I'll access it again. Yeah, this one. Okay, so if you haven't joined the room before, you need to click on the green join room button after you arrive at the room, and then you need to set up your environment. So for the environment, all we're going to be doing is we're going to be starting the lab machine because we're not using the attack box today. Well, we're not using the attack box right now because we're going to be using the attack box later. So click on the start lab machine button. And I guess we can read about what we're supposed to be doing here. So in this box, you will learn about brute force, hash cracking, and privilege escalation. Connect to the TryHackMe network and deploy the machine. Okay, we've done that, so we can click on this. So this room actually guides you through the network hacking process. So the first thing they want us to do is they want us to do some reconnaissance. So for reconnaissance, we're going to be using the Nmap program, and the Nmap program can be used to determine open ports and services on a remote server. So the first thing we need to do before that is we need to get the IP address for this machine. So they'll give us the IP address in just a sec. If you have any questions about any of the stuff that we're doing, please let us know in the chat, and I will try to answer your questions as best I can. Okay, so for the TryHackMe room, they've got a remote server at this address that we need to access. I'm going to click on this to copy the IP address, and then we'll go over to our terminal in Kali Linux. I'll call this terminal my Nmap port scanning terminal. We'll run Nmap on the IP address with some arguments. So when we run Nmap, typically what we do is we give a bunch of different arguments to the program to get different types of output. Essentially what we're doing here is we're scanning a remote server to figure out what ports and services are open on that server. And in this case, we're going to run it with these parameters here. So -vv to give us some verbose output before the scan is over. If you don't use this particular flag, you need to wait for the Nmap scan to completely finish before it shows you anything. This parameter here, -p- instructs Nmap to scan every port instead of default ports. And this tag over here, this parameter, -s_V, gives us the versioning information for whatever services that Nmap finds. So the last thing we're going to supply is a timing number, which is 4 in this case. So timing level 4 in Nmap is fast, but not too fast. So it's pretty much default kind of timing you want to use for these types of challenges. Okay, so when we scan the IP address, it tells us there are these open ports on the remote server. So 110, 143, a bunch of these different ones. We need to wait for the entire scan to come back before we can answer the first question in the exercise. So the first question asks us, search for open ports using Nmap. How many ports are open? So we can see from the answer format here that there's only one digit here, so it's between 0 and 9. Okay, so far we found 1, 2, 3, 4, 5, 6. We found 6 different services so far, but we need to wait for the scan to finish before we can answer the question. So while Nmap is running, it'll tell you how much time remains in its scan. So like a little while ago it said 1 minute and 43 seconds remaining. I don't know how accurate that is. Okay, and it also says which version of SSH is running. So this is something that we could get back from the Nmap scan, and we'll be getting that in just a second. Same thing with the version of Apache that's running and the distribution of Linux. Okay, we got about 43 seconds remaining before we can get the entire picture of what's going on. Okay, so I think we've identified 6 different services. 1, 2, 3, 4, 5, 6. So we'll try answering 6 for this first question here. 6. Nope, it wasn't 6. It says it's scanning 6 services. 1, 2, 3, 4, 5, 6. When Nmap comes back to us, it'll give us a lot of information, and we'll go through the scan results in just a sec. It also tells us to search for hidden directories on the web server. What is the hidden directory? So we might as well skip to this part as we can skip to this part while the Nmap scan is still running. So we're just going to go to another terminal. We'll call this our web app enumeration tab. And we'll run, so this is the IP address we're looking at. So we can run derb to try to find something on the web service. Then again, we didn't find a typical web port, so maybe, yeah, we didn't find a typical web port in our list of ports here. So the typical web port is port 80 or port 443 for encrypted web traffic, but we didn't find it here. So we're going to have to identify which one of these ports is actually running a web server. So it could be 110, 143, 143, 993. We could try the different ports in our web browser as well. So we can go over to here. Whoops. We do HTTP and then the IP address and then colon and then the port number. So we could try 110. Nope. We do 143. We could try, okay. So we actually got the results back from the Nmap scan. Huh. We actually didn't get very good results from the Nmap scan here. So we got these open ports, but we also got like TCP wrapped for the service, which means it's probably behind a firewall. What we need to do is we need to run our Nmap scan again. And we need to double check our IP address. So the IP address is here. The other thing that might have happened is I could have started my Nmap scan before all of the services were up and running, which means we would have gotten faulty results. So we'll just run... We'll run the scan again. So 995.25.143, are these different ports now? But we can go through and we can try these out and see which one is a web port. Okay, so we'll try 995. We can try 25. 25 is probably not it because 25 is associated with like email stuff. We can try 143. We can try 587. We can try 110. And we can try 993. Okay, so this is not... Are these the same 6 ports that we got from the other scan? 1, 2, 3, 4, 5, 6. Yeah, I wonder why we're not getting proper results from our Nmap scan. Okay, so this seems to imply that the server is running SSH and it's running some sort of web server. And then we need to look for hidden directories on the web server. Maybe we should try scanning with a different tool. So another tool that we could use is Nuclei. So we can run Nuclei host this. No. What is the command syntax? Nuclei U target. So U is the target. Okay. So we'll just leave this running in the background. Okay, haven't found anything yet. So if this, I mean, if we don't get anything good from this again, after we do our Nmap scan, we're gonna have to reset our host. We're gonna have to reset the box and then try it again. I really hope it doesn't come to that. Okay, so let's see, about this box. Getting a shell, privilege escalation, reconnaissance. So we're currently on the reconnaissance stage. Could not unmarshal interaction, data interaction. What? What is this? Huh. So Nuclei wasn't able to find anything. The other thing we could do is we could just try doing a simple ping. I'm pretty sure we do have connectivity to the machine. Oh, it's not responding to pings. That's interesting. This changes everything. So because if this machine is not responding to pings, then we need to do a different type of Nmap scan. So in the case that a machine does not respond to pings, we need to give this flag right here to just scan services without doing a ping first. Okay, and we discover different stuff. I can't tell if this is different stuff or not. It looks like the same stuff, like the same port numbers. Okay, so we'll just leave this running for a little bit, because each one of these Nmap scans takes a little bit. But that's interesting. It's interesting that the we can't ping the machine. Let's try it one more time. Yeah, it doesn't respond to pings. Let me take a look at my notes. I've done this machine before, but I think it was like it was a few months ago. I should have it in my notes over here. Because we're doing this as a demo. So walk through for TryHackMe. I don't have it online. I wonder if I have it on my local machine notes. Yeah, I do. Okay. You know, from my notes, it indicates that there should be... The notes indicate that there should be a port open on port 80. So if we go to HTTP, there should be something available, but there's not. Oh, you know what? I think I might not be connected to the same network. I think I'm experiencing some technical difficulties. Wow, SysOS Master, thank you for the gifted subs. Much appreciated, my friend. Let's give you a Jurassic Park to remind us about dinosaurs and computers.
It's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
Okay, so the lab machines are over here. What we need to do is we need to make sure that we're... Had to abuse the Twitch discount somewhere. Thank you. Thank you very much, SysOS Master. Alright, so virtual machine region, Oregon, okay? You're running virtual machines, you have no virtual machines. I think we were looking at... Oh, they're defaulting me to US West Oregon? Hold on, cancel. Okay, and we want to download my VPN connection. So open VPN, let's download the configuration file again. Oh, I'm not connected to Oregon. So they've got me connected to US West, and the key we have is for US East. So we need to download the configuration file again. Okay. So this is US West 2, the Chi-Hat regular. Alright, I was using the wrong VPN connection key. Sorry, everybody. You're not connected, that was the problem, I guess so. I guess we were supposed to be using this one. Okay, and now let's try to ping the machine. Okay, now we're connected. Jeez. What was I scanning before? It let me scan a machine on this IP address. I don't even know what the heck was happening. Okay, let's run the Nmap scan again. Okay, we've got different ports open now. Some random other machine. Yeah, I guess so. I guess so. Yeah, scanning other people's boxes, I mean, that was an honest mistake. So it looks like there's only 2 ports open on this machine. Sorry for the technical difficulties, everybody. Let's go back. Okay, so there's 2 ports open. And what version of SSH is running? So if we go back to the Nmap output over here, this is OpenSSH 7.6p1. So this is the version of SSH that is open that was asked by the room here. Okay, paste that in. And they're asking for what version of Apache is running. So Apache is the web server software, and the web server software is Apache HTTP D2429. I guess we can just provide 2429. Okay, and which Linux distribution is running? If we take a look back at the Nmap output here, this is Ubuntu, and Ubuntu is a very popular distribution of Linux. So Ubuntu. Okay, search for the hidden directories on the web server. What is the hidden directory? So what we're going to do is we're just going to use a very simple directory busting tool called derb. And we're going to look for, so there's an admin directory over here that we found using derb. So realistically, derb is, well, if you've got a fast connection, derb is a very good first pass. But if your connection is slow, you probably want to skip to a more advanced directory busting tool. But we found an admin endpoint. So let's go to the admin endpoint. So the IP address here, admin, and this is a login form. So because the name of the box is called brute, we suspect that we need to brute force our way into this login form. So the way we would do that is with specific like brute forcing tools. So let's see. Let's talk about this a bit. So brute forcing tools. So brute forcing tools try to find legitimate credentials. So these could be a username, or these could be passwords. And a very common brute forcing tool that we do in these CTF exercises is called Hydra. And Hydra can be used to brute force login forms, usually with a specific kind of syntax. Nullsec, hello, nice to see you here. What is up? Hope you're having a good day. And TGIF to you, happy Friday. If it is Friday for you. So typically what you would do is you would try to figure out what the login information looks like. So the login information for here, well, let's take a look at more tools, web developer tools, and we can take a look at the network tab. The network tab will let us know about any requests that we make to the web page. The train spilled some tea. Awesome, awesome. Okay, so we could try username admin, password admin, we don't know, and then we will click on login. Okay, and then we see here that there was a post request to the admin endpoint. So if we click on that, then we can go down to let's see, we're looking for the body of the post request. So the request, so our form data, user admin pass admin. So this is the type of data that we need to use when we're passing it over to Hydra to do a brute force attack. Okay, so and we also got the message, the error message, username or password invalid. So if we take a look at the Hydra command we're going to be using, it looks like this. Okay, so we run Hydra, and we provide a username with -L, and that's admin, because we're trying to brute force the admin's password. For the password, -P passes in a list, and we're going to be passing a list of 14 million of the most common passwords, which is a very common password list for CTF exercises like this. So the name of the file that we use is pretty famous. It's called rocku.txt. We provide an IP address. We provide the type of brute force, which is on an HTTP post form. We provide the endpoint /admin/index.php, the parameters user and pass, and this is where we put in our user parameter and our password parameter. The last thing we do is we provide an error message that it's going to check against. Username or password invalid. So it looks like this. We'll run it from our web app enumeration tab. And the only thing we need to do here is we need to switch out the IP address, because the IP address, the last time I did this, is going to be different from the one we have now. Okay, so when we run this attack, it's going to try the username admin and a bunch of different passwords from this password list over here. It's going to keep on attacking the web server until it finds a proper match. Okay, and we found one. So it turns out the login password for the admin user is Xavier. So let's go ahead and log in. So username admin, password Xavier. Okay, and what do we got? So it says, hello John, finish the development of the site. Here's your RSA private key. And we've got a flag here, THM brute forces key. We can take this and we can provide it back to TryHackMe over here. Where is it? So search for hidden directories in the web server. What's the hidden directory? So we found our admin endpoint. And then we can go on to task number 3. So find a form to get a shell on SSH. So what is the user password of the admin panel? So we were able to do brute forcing to find out that the credentials are admin Xavier. Okay, and it says crack the RSA key you found. What is John's RSA private key passphrase? We're going to be talking about this in just a second, but first we're going to submit the web flag down here because we found it on the website. Okay, paste it in. Okay, so we need to crack the RSA key that we found. So we go back to the website here, and there is a link to an RSA private key. What we need to do is we need to copy this over to our local host system. So what this is a key that would be used for login using SSH. So we could use this for terminal login. So this key file, we're going to copy the contents, and then we're going to create it on our system over here. So we're just going to create ID RSA. So that's the typical name for an RSA key, private key. We paste in the contents that we copied from the website, and then we save it out. Control X, press Y, and then press Enter. So the problem with the key is that we can't use this key to log into SSH because the permissions are too loose. So typically on an RD-RSA file, we would only want read access by the file owner. So what we need to do is we need to set the group permissions and the global permissions to none. We can do that with the chmod file. So change file permissions on a file. 666 or 600 means that the owner has all permissions, the groups have 0 permissions, and the global people have 0 permissions on ID RSA. So from here, we can use this to try to log into the server. So let me get the server IP address. Here it is. Okay, and maybe we'll use a new... We'll call this our SSH access terminal. Okay, so typically what we would do when we want to log in with SSH is we would do SSH and then the name of the user. We got it from the website. Their name is John. And then we provide @ the IP address. And because we're using an SSH private key, we would have to do -i and provide the name of the key. Okay, it asks us, do you want to continue connecting? The answer is yes. And then it says enter passphrase for key ID RSA. We don't know what the passphrase is for the RSA private key, so we can't log in. Because we don't know the passphrase and now asks for the password, we don't know what that is either. Okay, but what we can do is we can try to crack the password or crack the passphrase from the private key. The way we would do this is with a helper program. So the helper program, well, okay, let's talk about what we're going to be doing here. SSH private key cracking, or passphrase cracking. We found an SSH private key. This key could be used in the place of a password to log in as a specific user. This key has a passphrase that we don't know. We can crack the passphrase from the key using a cracking program. For example, John the Ripper. John the Ripper is the name of one of these password cracking programs. Okay, afterwards we can use the passphrase to log into the server. Okay, so this is how we do it. Oh, where was I? Okay, so from here we've got our IDRSA file. We don't know what the passphrase is, but we can use a helper program to extract the hash from the private key. So the name of the program is SSH to John on IDRSA. So if we run that, this is going to extract the hash from the private key. What we want to do is we want to put the output of this tool into another file called john.hash. Okay, and then we can use the John the Ripper program. So John with a specific word list, and the specific word list is the same one we use for the brute force attack, rockyou.txt, with 14 million of the most common passwords. We're going to be running it on john.hash, and John the Ripper is usually pretty quick. You'll find that password cracking attacks versus brute forcing attacks are much faster. So when we run this, it finds that the passphrase is actually rock and roll. Rock in roll. So we can use this passphrase to log in as the John user. So let's go ahead and do that. Okay, the passphrase is rock in roll. So in this case, when we're typing out the password, we don't see any output from the terminal. This is normal in Linux. And now we've got access to the Brute server now as the John user. Okay, and we also have access to our user flag over here. So in these CTF exercises, when you need to break into these boxes, typically there are two flags that you need to access. One for regular user access. It's usually called user.txt. And the other flag that we need to access is the root users flag, which we get after we get super user access. So this is our flag. A password is not a barrier. So we'll just copy this and then we'll go back to TryHackMe. Okay, user.txt is this. We'll submit it. What is John's RSA private key passphrase? So this was rock in roll. Okay, so the last thing we need to do is we need to do privilege escalation, because on these type of network CTF exercises, network CTF box challenges, okay, you start with 0 access, find a vulnerability in the system, get initial access through that vulnerability, and then escalate privileges. Is that, wait, how do you spell privileges? Privileges. Escalate privileges to super user, and then challenge finished. So these are the typical steps you would take. I guess the other step in here, start with 0 access and then do initial scans on the target. Find a vulnerability in the system, get initial access, escalate privileges, challenge finished. Privileges are provolone, not sure. I mean, provolone is much tastier than privileges most of the time. I do like my provolone cheese. Okay, so what we need to do is we need to do privilege escalation here. Okay, so find a form to escalate your privileges. What is root's password? So if we go, where were we? SSH access over here. So what we can do here is we can try to figure out if the John user has specific root user privileges with the sudo command. So the user John can run the following commands on Brute. As root with no password, they can run bin cat. So let's explain what the sudo command does. Sudo access and privilege escalation. Sudo lets you run certain commands in the context of other users. Typically, sudo lets you run commands as the super user, but it doesn't always let you run commands as a super user. So in this case, we can run the cat command as the root user. And if we can run the cat command as the root user, this is an example of privileged file read. And privileged file read means that we can read any file on the system. We can't necessarily modify any files, but we can read any file on the system as long as we know that it exists. So I think what we need to do here is we need to we need to read the root user's password, or not. Well, we need to read the root user's shadow file. Sorry, not the root user's shadow file, the shadow file in general. I'll explain what this is in just a second. Okay, so sudo bin cat on etc shadow. So what this is, what the shadow file is here, it's a list of it's a list of different users on the system, as well as their password hashes. So if you're able to crack a user's password hash, you get their password. So what we do is we copy the entry for the root user here, and then we're going to copy this to our own system. So in our own system, I'm just going to call this my cracking tab. Nice little box. We need to find a file that hashes, the shadow. So we can, I mean, there are a number of different tools we can use to extract the hash. Well, to format the hash into a form that is suitable for the password cracking programs. So let's see, I'm going to create a file called shadow, and I'm going to put the root user's information in here. We're going to save that out. And then we're also going to create the password file. That is the information about the users. And we're going to get it from the server. So cat, etc. password. This has some additional information about the root user that we need to pass over to another program that we're going to be using. So we're going to copy this. And then we're going to create this file, password. Pass this in, and then we're going to use another we're going to use a tool to extract the password hash in a format that is suitable for the password cracking programs, and that program is called unshadow. So unshadow password shadow, and then redirect it into another file called root.hash. Okay, and this should get us a proper hash that we can pass over to the password cracking programs. So for example, John the Ripper or hashcat. So I think we can use John with the word list rocky.txt and then use it to crack root.hash. And we're able to get the password. So the password for the root user is football. We're able to crack this because we were able to read the shadow file that has the password hash. Okay, so that means we can... What is root's password? We can answer this question, football, very timely. And then we can log in as the root user and then get the final root.txt file. So here we'll do sudo, well, we're just going to switch user to root. It's going to ask for the password, football, and now we're the root user. Who am I? We're root. Foosball, foosball is for the devil. I guess so, I guess so. So we're just going to enter the root directory. Sorry, cd root. And the final file we need to access is in here. root.txt. Cat root.txt. Okay, and this is the flag, the final flag for this challenge. THM privilege escalation. So we'll copy this and we will paste it in, and that finishes the room. Okay, so let's talk about what we did in this room. Over here. So in this room, we scanned the remote server. We found an SSH service and a web page service. We did dir busting on the web server and found the admin endpoint. We used the Hydra tool to brute force the password for the admin user on the web app. We obtained an SSH key from the server. We cracked the passphrase for the SSH key with a tool called John the Ripper. We got direct access to the server as the John user. We found this user had sudo permissions with the cat command. This allowed us to read the password hashes for the other users, including the root user. We cracked the password hash for the root user, and then we authenticated as the root user, ending the challenge. Done. Okay, so if there's anything about this challenge that you have questions about, if you have questions about any of the steps that we took to finish the challenge, let us know in the chat. I'll try to explain as best I can what was going on. Okay, but we finished. All right, so we've got about 10 minutes left before we need to start the next part of the stream, and I think we're gonna try another one of these puzzles over here. Okay, so the next puzzle is puzzle number 38. And let's see. So when in need of answers, always go to your local library. But what's the library hiding again? Huh. What is this? This is a... oh, it's a link puzzle. It's a path puzzle. Okay. So everybody, if you want to do the same puzzles we're doing, they're over here. So this is a simple path puzzle, also known as a Hamiltonian path puzzle. Trace a path from the entrance to the exit, passing through every space along the way. So we need to cover every one of these squares while we make a path to go to the exit. Okay, so the path must not pass through restricted cells, and the path can never branch nor cross itself. Okay, so from the looks of this puzzle, let's make it as big as we can. Atvow says, I wonder why you teach. For humanity advancement? I mean, I enjoy teaching. I also think it's important. It's important for people who are beginning cybersecurity to have a good resource for learning about the basics. People in cybersecurity, after they've learned the basics, they tend to have a good foundation for learning on their own. But for beginners, it can sometimes be hard to tell. Okay, so from the looks of the puzzle here, I think we need to go this way first. No, this way first. Because from here, we need to pass... how do we do this? This way. No, we can't go this way first. Never mind. We need to go this way first. Okay, then go up here. then pass over this way? Yeah, like this. And then get to the end like that. Oh no, wait. Hold on. I missed these two. There we go. Okay, so we covered everything. Okay, great. We can move on to the next puzzle. So certain types of puzzles really make it difficult. Oh, this is another star battle. I like these ones. Okay, so this is a star battle. So place 1 star in each region, ensuring that there are no other stars in the same row or column, and that there are no 2 stars next to each other, including diagonally. Keep in mind that there can only be 1 star in each row, there can only be 1 star in each column, there can only be 1 star in each region. Stars cannot be next to each other vertically, horizontally, or diagonally. And we can mark off cells that can't possibly have stars. Okay, so typically what we do in one of these puzzles is we try to find a region where... Well, this one looks tricky. Because what we like to do is we like to find a region where there are only 2 possibilities, and then isolate from there. But I don't think we can... Oh no, here it is. Okay. So we got 2 here. So there's only 2 possibilities here, which means we can eliminate cells that that are shared between these 2, and then we can eliminate this entire row, because no matter if it's on this cell or this cell for this region, it eliminates the rest of the row. Okay, and from here we see there is we're looking for another region that only has 2 possibilities now. Where did we create that? So for this region there are 3 possibilities. And if the star is in one of these 3, if the star is in one of these 3, then there's this space and this space that are... No, there's only this space that is shared between these 3. So this has been eliminated. And where else can we do this? I don't think there's an... Because we want to be absolutely certain before we start putting down any stars. How can we do this? There's 4 here. Okay, so in this region, there are these 3 stars. So is there any one... There's only one square that is shared between... There's only one cell that is shared between these three cells that we can eliminate. Is there something I'm missing here? There's got to be some sort of logic I'm missing. Okay, let's start reading some hints. This puzzle will unravel as soon as you place the first star. Look closely at the small region with only 2 cells. So this small region with only 2 cells, this blocks off these. And it blocks off this. Okay, it says we know a star will be placed in one of those 2 cells in the smallest region. Bet, can you figure out which of those 2 cells? Which of those 2 cells? So is it going to be left or right? Is there something that tells us it has to be the left or the right? Can you figure out which of those 2 cells? I don't know. I don't see. That it absolutely needs to be either the left or the right. Placing a star in one of those cells will block another region completely, making the puzzle unsolvable. Really? Okay, so if we put it here, then it blocks off all of these. So does this make one of the regions unsolvable? Oh, no? I'm not sure. Oh, okay. I see. So if we put it down here, then everything here is blocked, which means it can't be the right star. So it has to be the left star. So how does the game work? The game works, you have to put 1 star in each one of these areas, which are demarcated by the black lines. We need to find some sort of logical way to figure out where we're supposed to put these stars. Okay, so if we put this star down here, that blocks off all of these cells around it. Okay, and then that means that this star has to go here because all these other cells are blocked, which means we can block off all of these, which means that this region has to have the star in this row, in this cell, which means we can block off all of these, and that means that this region can only have the star in here, which blocks off all of these. And then this region only has one cell left. So we can put that star down here and then block off these. Reminds me of Go a little bit. So this region only has this one left, which means we can block off all of these. And then this region only has 1 cell left here. Which means we can block this off, and this, and this. Which only leaves this region up here, and this region over here. So it's not this one for the top region, because if it is this one, then it blocks off the possibilities for the bottom region. So this has to be the top, and because well, this has to be the top, and because we've eliminated everything else, this has to be the bottom corner square. Atval says, how does one defend the hard levels of Battleship on Game Boy No Color? How does one defend the hard levels of Battleship? I don't know. I haven't played that game. Okay, and we're done. That was interesting. That was interesting. I learned a new rule for the star battles. If you want to try this out yourself, Game Boy, the original Game Boy Battleship game. I don't know. I don't know how to. I haven't played that game before. Okay, so that's done. We might come back to some puzzles later, but we're going to be doing HackerFrogs AfterSchool now. So HackerFrogs AfterSchool is a program that I put together that talks about different cybersecurity topics. So this course we're doing right now is for network hacking. We're currently doing session number 5. And let me go ahead and set up the timer for that. So topic 3 is here, and topic 4 is on deck. Okay, so this is network hacking session number 5. So we're talking about password cracking in this session. So this is the 5th session for network hacking. Let's go over the concept we covered in the previous session. So in the last session, we talked about remote shell access. We talked about reverse shells and bind shells. A remote shell is a command line interface access. A remote shell is command line interface access to a remote server. This allows OS commands to be run through the remote shell. So this is what we're aiming for when we do our network hacking exercises. We talked about reverse shells, and reverse shell access is where a listening port is created on the local host, and the connection is established by the remote host connecting to that port. So basically you get the victim machine to connect to your attacker machine to create the connection in a reverse shell. Bind shells are the opposite. So a bind shell access is created when the remote host opens a networking port, which is then connected to by the local host. So in the bind shell concept, the remote server or the victim machine, it opens up a port which the attacker machine then connects to create the shell connection. So in this topic, we're going to be talking about. Thank you very much for following on Twitch. Renans, thank you, much appreciated. So in this session, we're going to be talking about a number of different things. What is password cracking? We're going to be talking about the CrackStation website. We're going to be talking about cracking password protected zip files. We're going to be talking about cracking Linux password hashes, and we're going to be talking about cracking SSH private key passphrases. So these are the topics we're going to be talking about. It's a lot of cracking. What is this password cracking thing? Password cracking is the act of determining the plain text of a password hash by hashing a string and comparing it to the password hash. So if the plain text password is HackerFrogs, we can use MT5 hashing with that plain text, and if the resulting hash and the hash password is the same, then we've cracked the password. So if we get a hash password in MD5 that looks like this, and then we hash the word HackerFrogs, and it's the same hash, then we've determined what the plain text password is for this password hash. Okay, so we're going to be using a TryHackMe environment to learn more about cracking passwords, and the room that we're going to be using is called Crack the Hash. Let me get the link for everybody. So this means you're going to have an account over at TryHackMe, but you're not going to need to pay for a subscription because we're using a free room. Okay, so this is the room over here. So just a second, I'll show you what this looks like if you've never used this room before. And I'm just going to disconnect from my TryHackMe connection. Okay, so over here, we're going to click on Options. Whoops, well, I mean, you don't necessarily need to do this. Just a second. Reset the progress, leave the room. Atval says, would TryHackMe put me on a list like they do with all the Tor users? TryHackMe, I mean, if you use any platform and you give them your information, then they have your information. If you think that they're not going to be using it for good purposes, you can give them fake information, or you can use like a burner email account that you're not really using, if you're worried about that. You're on a list for asking. Yeah, I'm sure they'll put you on the list now. Never mind. Okay, so anyways, after you arrive at the room, you can click on Join Room to get access to the features of the room. And then what I want you to do is I want you to start the attack box. The reason we're using the attack box is because it's an environment where everybody's got access to the same tools, and not everybody's got access to a cybersecurity distribution of Linux. But we're going to be using the attack box in this case. So click on Start Attack Box up at the top of the room. And we're going to have to wait for a little bit of time for this attack box to initialize. But while it's initializing, we can talk a little bit about what we're going to be doing in this workshop. Am I looking at the right thing? No, I'm not. Just a second. Okay, so the first thing we're going to be talking about is the CrackStation website. So CrackStation is kind of like an easy win kind of solution for password hashes, or for hashes in general. So CrackStation is a good website to use if you're dealing with insecure hashing methods such as MD5 and SHA-1. It's a website that can help you crack hashes, especially hashes that are well known. Okay, you can also identify hash types using various tools like Hash Identifier or the hashes.com website. So let's go ahead and we'll do a demonstration for it in just a second. Actually, wait. Maybe I can just do that over here. So let's suppose we've got a typical easy password to crack, such as like let me in, and we hash it using the MD5 method. So MD5 sum on Linux, we get this password hash right here. So I'll pass it to everybody in chat, just in case you want to mess around with it yourself. So we can take this password hash and we can pass it over to like a web app like crackstation.net. We can paste in the hash, and then we can click on the crack hashes button. So it's looking for cars. That's a car, that's a car, that's a car. Okay, and then click on crack hashes, and it was able to identify that this hash was originally the text let me in. Beauty Bike, I have an email but not a password. How can I hack the password? I have an email but not a password. How can I hack the password? I mean, are you talking about trying to log into somebody's email? In this case, we're not doing a cracking attack, we're doing a brute force attack. Although brute force attacks and cracking attacks are kind of similar, brute force attacks are different because they're much more easily detected. Cypher asks, how do I get money in cybersecurity without a job and without breaking the law? Without a job and without breaking the law. I mean, Cypher, I guess you could talk about... You could do something like bug bounty hunting. So bug bounty hunting, well, your job is technically working for yourself. You're not working for somebody else. The problem is that you could potentially work for months or years and not make any money. So bug bounty is not a good choice, especially as a first job in cybersecurity. Okay, so we can also try to identify what this hash is. So let's suppose we don't know what this hash is. We could run like hash identifier. Ah, it's hash dash identifier. Okay, so they're looking for a hash. So it says possible hash is MD5. So these hashes right here, we need to identify it first before we can crack it. Well, I suppose we don't necessarily need to identify it first, but identifying it first makes it a lot easier to crack. Okay, and the other thing is there's another website called hashes.com where you can crack hashes. So you supply a hash, and then you need to do the captcha check here, sure. NNVHRT, submit and search. And it says one hash was checked, so it found that this hash right here is let me in. But it wasn't able to identify for us what the actual hash method was. But that's fine. Okay, so let's go back to TryHackMe. So our machine is finished initializing. So we can click into the terminal and we can hit enter. What we're going to be doing is we're going to be working from the terminal in this case. So we want to click on one of the terminal shortcuts. So we'll use the one at the top here. And from here we can run our terminal commands. Okay, let me see if I can resize this window. Okay, and what are we doing next? So we can identify the hash types with hash identifier or hashes.com. We can also use CrackStation for quick wins on password hashes. And we're going to be talking about cracking a few different types of file formats, because different file formats can be password protected, such as zip files or SSH passwords or Linux passwords. We'll talk about how to crack methods we can use to crack these. So zip files are a common file type that can be password protected, and we can extract the hash and then crack the password using a tool like John the Ripper. Okay? So Linux password hashes can also be captured and cracked, and this technique is used in network CTF exercises. So sometimes on these CTF boxes you need to crack the password hashes of users on the Linux system. And the last type of file type that we're going to learn how to crack are the hashes for SSH private keys. So another common file that can be cracked are the passphrases for SSH private keys, which allow users to log in. Atha says, so unique passwords, yeah, I would say that if you have a unique password, they're not going to have the passwords on the rainbow tables they use for these password cracking websites like hashes.com or, I don't know, what was it called again? Crackstation.net? Because what Crackstation.net and other tools like this use to try to identify what the original plaintext is they look for hashes that have been cracked before and put into their database. So if we give Crackstation.net like a unique password, it shouldn't be able to crack it. So if I go to my Linux terminal and we echo out some random, well, what's a random number and letter password? Hold on, let me get one from Google. Give me a 8-letter random alphanumeric. Actually, you know what? It's quite possible that whatever we get from Google is going to be crackable. Because that would be weird. My password is the same as Shyhat's. Oh, okay. Let me in, sure. Random alphanumeric generator. Let's try this. Okay, so string length will do 8. Number of strings 1. Output in unique characters in string, generate random string, give it to me. Okay, so let's try this. Okay, you can also do random. Oh, you can use the random Linux device. That's pretty cool. Okay, so we'll try this, and we will MD5 sum it. And this gives us the MD5 hash for this random sequence of numbers and letters. Let's see if this can be easily obtained from CrackStation. Okay, Shota, nice to see you here. And it was unable to crack it. Okay, that's good. It's good that it doesn't have like random numbers and letters in its rainbow tables. But okay, so this is what we're gonna do. We're gonna create a number of different files that we can crack using a script. Let me get the script. Where did I put these things? Here we go. Okay, setting up the hash cracking files. So copy the code below. So okay, here's the link. Go ahead and click on it, and then scroll down to part 1, setting up the hash cracking files. Step 1, copy the code below. So there's a coding window here. You want to click on it, and what we're doing is we're creating a bash script that is going to create the different files we want to crack. Okay, after you copy the code, go back to your TryHackMe window, and then click into the clipboard over here. Paste in the bash script, and then click on this arrow key down here. Then click on your terminal, type in nano script.sh because this is a bash script, and then paste in your code. Okay, so after you've pasted in the code, hit the Control X button to save out your script, press Y, and then press Enter. And then we need to run the script. Tufacho, nice to see you here. Okay, to run the script, just do /script.sh. Okay, permission denied. Permission denied. Oh, is it not executable? Okay, we need to make this script executable. chmod +x /script.sh. Okay. Atva says, theoretically, quantum computing power can try all the possible passwords. I mean, once quantum computing is here, then it can crack hashes very, very easily. But at that point, we're going to be using different types of cryptography that are quantum secure. Okay, so let's run script.sh. So /script.sh. Okay, where do we get this bad password check from? The password fails the dictionary check. It is based on a dictionary word. Adding zipflag.txt. I wonder where we got this error from. One of the commands we ran got us this error. Okay, so we should have some different files now. So we should have an IDRSA file over here. We should have a zipcrack.zip file, and we should have hackerfrog.password and hackerfrog.shadow. And we should have a HackerFrog user added to our system. So let's cat etc password to make sure that we've got a HackerFrog user here. Okay, great. Okay, so let's go ahead and try to crack these 3 files. So the first type is we're going to try to crack zip file password hashes, and this is how we're going to do it. Whoops, where are we? So zipcrack.zip, this is a zip file that we want to access. So typically on these zip files, we just have to type in unzip and then the name of the file. But it asks us for a password. We don't know what the password is, so we can't get access to it. So what we want to do is we want to unzip this, get access to the zipflag.txt file. So what we can do is we can extract the hash, the password hash from the zip file. So there's a tool called zip2john. And if we run zip2john on zipcrack.zip, it'll get us the password hash for this file. So what we want to do is run zip2john space zipcrack.zip and then redirect it using the greater than sign to zip.hash. Okay, so afterwards, we have a zip.hash file with the hash file for the zip file. Okay, and we're going to use another tool to crack this hash. So the tool is called John the Ripper. So we do John for John the Ripper and then -- word list equals user share word lists rocku.txt, and I'm not sure if this is the exact location, and we run it on zip.hash. Note passwords longer than no such file or directory. Okay, I wasn't able to find rocku.txt. Let me see if I can find it. Oh, wait. I did a little typo. Okay. Don't do typos when you do hacking, otherwise you won't get to hack. Let me go back and let's correct this. Okay, and we're able to find a password for this. So everybody, if you're finding it hard to follow along with the commands I'm using, all the commands I'm using can be found over in this file. I make so many typos. Yeah, it's tough. So this is why we want to try to copy and paste as much as we can, because when we copy paste, usually we avoid making typos. Okay, so if you take a look at the different steps inside the MD file, it'll tell you all of the different commands we need to use to do these exercises here. Okay, so we what did we just do? We just found out that the password for this zip file is Star Wars, so we can unzip this zip file using Star Wars. So unzip zip.crack zipcrack.zip. And the password is Star Wars. Remember, when you type in a password in Linux, you're not going to see any output from the terminal. This is normal. Just type in Star Wars and hit enter. Okay, extracting zipflag.txt. So if we read that, then we get that the HackerFrogs flag. Frog zip hash cracked. Done. Great. Okay, so let's move on to the next exercise. So the next exercise, after cracking zip file hashes, AdVow says, when someone offered me a hacking program, I deleted it or I downloaded it. Big mistake. Was it an executable? Did they give you an executable to run? Okay, so the next thing we're going to learn is how to crack Linux password hashes. Ah, okay. Yeah, I mean, I've fallen for it before too. I mean, maybe back in 2005? Yeah, maybe back in like 2005 or like 2010. I still would have fallen for stuff like that. It was supposed to be a dictionary list. Oh, okay. Okay, so these Linux password hashes, we demonstrated this a little while ago. So let's suppose you're on a system and you take a look at the etc password file to let you know what users are on the system. So you see that there's this user called HackerFrog on the system. And for some reason, you were able to get their password hash. So the password hash would typically be, it would be in the etc shadow file. So the password file here, the shadow file here, if you've got access to both of these files, then you can extract the hashes from the shadow file and then try to crack the Linux password. So typically what you would do, if you've got the password file and the shadow file, is use the unshadow tool to extract the hash from the shadow file. Thou asks, what happened? I'm pretty sure that I had like pop-ups, and I had pop-ups on my computer, and then I had like my browser was taken over. And then what I did to get rid of it was reinstall the operating system on my computer. But that was a long time ago. Okay, so the HackerFrog.password file. Whoops. Is this. So this is the password portion. And then there's the shadow portion. So cat HackerFrog.shadow. This is the password hash for the HackerFrog user on the system here. So what we need to do is we need to run unshadow. So unshadow is a tool that you can find on a lot of security distributions of Linux to do this. So unshadow HackerFrog.password HackerFrog.shadow, and make sure that everything is spelled correctly, because apparently I don't know how to spell. Okay, and then redirect it into HackerFrog.hash. Okay, if we cat it out, then this is the hash we're going to pass over to John the Ripper to try to crack. Hunter Bill, hello, nice to see you here. Hope you're having a good day. We're just figuring out how to crack passwords. We're trying to figure out how to crack a Linux password now. So after we create our password hash file, we can pass it over to John the Ripper. So it's John -- actually, let's just get the John the Ripper command we did last time. Okay, so it's the same John the Ripper command using the same word list. The word list is rocky.txt, but this time we're running it on HackerFrog.hash. Victor86, happy hacker. Happy Hacker Day to you. Okay, so we run John the Ripper, and it's able to get the password for the HackerFrog hash, which is Hollywood. So we can log in as this user by using the su command as HackerFrog. So su HackerFrog. And this switches us over to HackerFrog. Okay, I guess the other thing we could do is we could, to figure out if this is actually their password, what can we do to trigger a password? To trigger a password prompt. hold on. Linux, what command always triggers a password prompt? Actually, wait, I think I know. So if we try to do sudo su or sudo l, it'll ask us for a password. Yeah, okay. So this is where we test that this is the correct password for the HackerFrog user. So we type in Hollywood, and it says, sorry, HackerFrog may not run sudo. So this is so we were able to log in as the HackerFrog user, which means we were able to crack their password successfully. Okay, Hunter Bill asks, I got one question. How do you keep motivated? If you love what you do, you'll be motivated. If you're not motivated about something, you need to ask yourself why you're doing it. And if you might come to the conclusion that you're not actually you're not actually motivated to do it, and then you can figure out that you're not passionate about something anymore. But if you're passionate about something, if you've got good reasons for pursuing it, then you'll find a reason and you'll get your passion back. I mean, doing anything for a really long time can lead to burnout. And during those periods of burnout, you can just step away. Step away, try doing some other things, rest, relax, don't do the thing that burnt you out, and then come back to it later. If you find that it's hard to come back to it, then that might be a bit of a problem. Okay, so from here, we're the HackerFrog user. So, but we want to become the root user again because HackerFrog doesn't have nearly as good permissions. So we'll just type in exit to become the root user again. So who am I? Root. Great. Nullsec says, I've never found anything I want to do all the time. Sometimes you have to push yourself. Sometimes you do have to push yourself. Sometimes, especially when you're studying something and you're not getting it, it can be very demotivating. So if you have an example, then maybe I can better answer your question. I assume that you're talking about tech topics. So the tech topics in particular, they're really tough because it feels like you can never learn everything because there's too much information out there. Just know that you just have to accept that the fact that you'll never know everything, but you can know more than you know now. Okay, so the last type of file that we're going to learn how to crack are SSH private key hashes. So in network hacking exercises, it's very common that you'll capture an SSH private key that you can use to log into another system. Only the SSH private key has some sort of passphrase that you need to input to use it. So another common file that can be cracked are the passphrases for SSH private keys, which allow users to log in. Okay, let's go ahead and demonstrate this. So back at the TryHackMe terminal here, we've got an IDRSA file. So IDRSA is a very common name for these type of private keys. So if we take a look at the contents of the private key here, we can see that it's just a big jumble of base64 encoded information, but you can identify a private key because they usually start with this header here, begin OpenSSH private key, and at the end it says end OpenSSH private key. Shota says, thank you very much for streaming. I have to go. I will come next time. No worries, Shota, and hope to see you next time. Have a good one. Okay, so the SSH private key here, we can extract the passphrase, or we can extract the hash for the passphrase with another tool called SSH to John. So this is going to output a hash that John the Ripper can use, and John the Ripper is our preferred program for cracking hashes. So let's see if it exists. Okay, so it exists, so we can do SSH to John on IDRSA, and this is going to give us our hash. What we want to do is we want to pass this off to another into another file. So we'll do the same command, but we'll redirect it into key.hash. Okay, so that's SSH to John, ID RSA, redirected into key.hash. So afterwards, if we take a look at key.hash, this is the hash for the private key. So we're going to crack it using John the Ripper. So let me get the command for John the Ripper. Okay, so it's the same John the Ripper command that we did before. We just need to change out the name of the hash file. So in this case, it's key.hash. So it's John -- word list, and then user share word lists, rocky.txt. We run it on key.hash. So most of the time, the cracking process is very quick, and the brute force process is very slow. The difference between cracking and brute forcing is that cracking is done offline, and brute forcing is done against online services. So this is taking longer than usual. Hunter Bill says, I was a mechanic for 5 years and loved cybersecurity. I left my technician job to have time to learn cybersecurity and get certifications, but sometimes motivation is lacking sometimes, I don't know. Oh, interesting. So when you say mechanic, are you talking about car mechanic or like a mechanic for another type of industry? Let me know. I'm interested. Okay, so you left your technician job to have time to learn cybersecurity and get certifications. I mean, diesel tractors. Oh, okay, that's very cool. But what kind of cybersecurity do you want to do? The question is, what kind of job do you want to aim for? Are you aiming for like a security tester type of role? Are you aiming for incident response? Are you aiming to be a forensics analyst? It's very important to know where your goal is before you get into cybersecurity, because the training for different types of cybersecurity roles is very different. And you don't want to learn stuff that is not relevant to the role that you want to get in the future. Wow, this is taking a long time. Okay, we'll just leave this running in the background. So why are we doing this? Why do we do password cracking / hash cracking? Okay, in most cases, when the quote-unquote bad guys breach web servers and applications, they don't capture plain text passwords. They capture password hashes. Passwords are usually hashed at rest when stored by web apps. For example, the database. The database stores hashed passwords. So we can figure out what the hashed password originally was by doing hash cracking. Okay, and should be encrypted at rest, not just hashed. Encrypted. You mean encrypted using another method after the hash? I didn't know that was that was the standard as well. I guess I need to educate myself. Okay, tractor repair is an independent repair technician. That would require reverse engineering skills these days for the pwnage. Okay, did we crack the thing? Yeah, we cracked the thing finally. Okay, so we found out that the passphrase for this IDR for this passphrase is Tweety Bird. We don't have an example to double check this, but we do know that we got the password from John the Ripper. Encrypted at rest is a standard for many PIA info. Okay. Okay, so if you have any questions about any of the stuff that we were learning today, another good resource for learning about password cracking is over here. Let me see if I can get those education resources. Where'd I put that? GitHub. Oh, why is this not autofilling? So we have CrackStation. There's also... So I think I filed this under cryptography. Here we go. Cryptography utility websites. So crackstation.net, hashes.net, decode.fr, and then I think there was another one called Tunnels Up. Where'd I put that thing? Oh, I think I put it in my tools. I also have a list of different cybersecurity tools for CTF challenges. Yeah, there's another website that's very good for identifying different types of hashes called Tunnels Up over here. So this is another tool to identify hash types, enter a hash to be identified. So for example, if we did like a MD5 hash, or sorry, a SHA-1 hash, say. So we do, say we do echo -n let me in, and we pass it over to SHA-1 sum, and we get this hash. We can pass this in to Tunnels Up and try to have it identify what the original value was. So over here, analyze. So hash type is SHA-1 or SHA-128, and does it identify what it originally was? Huh. Wait. Oh, okay, this is just the hash analyzer. It doesn't actually tell you what the original value was. I think there's another tool on here as well. So hash analyzer, this is just hash analyzing. Okay. Tool to identify different hash types. Great. All right, so let's wrap up. So let's review the network hacking concepts we learned in this workshop. So password cracking. Password cracking is the act of determining the plain text of a password hash by hashing a string and comparing it to the password hash. So a couple of different ways to identify the type of hash being used include using CLI programs like Hash Identifier and the hashes.com website. So there's a few different websites you can use. Never rely on one website or one tool. You always want 2 or 3 tools just to make sure that if one of your tools fails, you can always back up to another. So we talked about cracking zip file password hashes. We talked about cracking SSH private key hashes. And we also talked about cracking Linux password hashes. So we're going to go to the other side of brute force attacks in the next HackerFrogs workshop. And in the next HackerFrogs workshop, we're going to be learning how to do online password brute forcing attacks. So what's the difference? So cracking versus brute force. Cracking is an offline attack, which means that you don't have to be online to conduct the attack. And brute forcing is an online attack, which means you have to interact with whatever service that you're brute forcing while it's online. So brute forcing is inherently more difficult / slower than cracking, because there are more obstacles to brute forcing than cracking. So for example, one thing that gets in the way of brute forcing is that you can only brute force as fast as the system, as the online system allows. Another thing that gets in the way of brute forcing is that there are a lot of different brute force protections. So for example, with the brute forcing SSH, there's a certain program called fail to ban that can be implemented to prevent brute force attacks on SSH. There's also account lockouts that prevent accounts from being accessed. So these are both types of protections that you can't implement for cracking attacks, but you can for brute forcing. Okay, Advow says you can run through inspect element password revealing. Inspect element password revealing. I mean, yeah, I guess so. For very badly implemented applications, sure, yeah. Anyways, we got 15 minutes left, and you know what? Maybe we can do a little bit of puzzle solving in that case. Hold on. But anyways, this is we're going to be doing online brute forcing attacks for the next session, and the next session is going to be on Wednesday of next week. So we've already published a schedule for the next week. So this is week number 28. And we've added a new stream to the schedule. So before we were doing 2 streams a week, we're going to try doing 3 streams a week. So we're going to do Co-working Tuesday, where we do co-working and hangout. And it's a more chill stream where it's just hanging out and learning one topic. And in this case, we're going to be learning some C programming. Nasty Code is just subscribed on YouTube. Thank you very much, Nasty Code. So we do a stream on Tuesday, a stream on Wednesday, and then a stream on Friday. So on Wednesday, we're going to be doing our brute force attacks HackerFrogs AfterSchool session. So stay tuned for that, and yeah, that's going to be next week. If you want to take a look at this schedule, it's over here. It was a cool stream, if at a weird time. Yeah, I mean, it's hard for me to find time to do live streams. This kind of live stream, which is late at night for me, it's a lot easier for me to find time when everybody else has gone to sleep. Anyways, let's do some puzzles. Yeah, I mean, the time is what it is. Okay, as they set off from the library, our hero gets the uneasy feeling. Again, just a precaution. They take an odd path back to Greg's house. Oh, what is this? Hunter Bill says, I didn't know that you were in Canada. Same here. Oh, you're in Canada too, Hunter Bill? Are you in the on the West Coast or the East Coast? Benadryl in their food. No, I would never do that. Okay, so what is this? So this is an odd path puzzle. Deja vu. This puzzle genre was invented by Thinky Dailies. Oh, it's a new type. It was inspired by the narrative's reference to an odd path. Start with 1, write the repeating sequence 1, 2, 3 to form a path from the entrance to the exit. Numbers in black cells indicate how many odd digits should appear next to them. Some numbers along the path are given. Okay. You're on an island. Easton and you're on an island. Okay, there's not... Anyways, I will, I'll just keep that as a thought to myself, Hunter Bill. Okay, so the path must contain the sequence 1, 2, 3, 1, 2, 3 repeated from the entrance to the exit starting from 1. Not all cells must be filled, so we just have to create a path and then get to the exit 1, 2, 3, 1, 2, 3. Okay. Numbers in black cells are not part of the path and indicate the amount of odd digits next to them vertically and horizontally, not diagonally. Okay, so we need to keep in mind these rules. Some numbers along the path are given. The path must use them, so we need to use these numbers here. The path can never branch nor go through the same cell twice. Okay, so let's try to give this a go without taking any hints. Once again, this is the puzzle. You can try to solve it yourself. This is a difficulty 3 puzzle out of 5. So this says that there are 2 odd numbers. 2 odd numbers. That's weird. So we do 1, 2, 3. 1, 2, 3. We're not going in this direction because there's a 2 over here. So I think we're going this way and then down. 1, 2, 3. Okay, so this is fulfilled. 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. 1. Oh. This doesn't work. We need one more odd number to be beside here. So we're not going this way. Are we going this way? No, we have to be going around here, right? Struggle bus loop? Okay. Thank you for following on Twitch, Ghost Noob. Thank you very much. You know what? Let's do a Hack the Planet just for fun.
Hack the planet! Hack the planet! Shut up and get it!
1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3. Oh, okay. So, this is kind of weird. So there's a 3 here. We need to circle around this. Okay, let's restart. We also need to move down here eventually. So 1, 2, 3. 1, but we can't go directly in this direction. So maybe 1, 2, 3. 1, 2, 3. 1, 2, 3. And then move in this direction. 1, 2, 3. 1, 2, 3. And then here, 1, 2, 3, and then we go to the exit. Yeah, I think this works. Yeah, I think this works. Okay. So 1, 2, 3, 1, 2, 3, 1. Oh, it's not right. Oh, we don't have it here. This one doesn't have enough odd numbers. Okay, so we need to find some way to... Okay, we need to go back. So we go 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3. No, we go here first. 1, 2, 3, 1. Okay, let's restart. Which path do we want to take? Ghost Noob, hey, nice to see you. What is our OS? We're using Kali Linux right now as our machine, because it's got all the security tools. We don't have to bother installing them manually. Our main OS, so I'm running Kali Linux on top of Windows. 1, 2, 3, and then 1, 2, 1, 2, 3, and then 1. Oh, we need to loop back. Okay, let's see. Endeavor OS. Do you like Arch-based OSs? I've never used Arch-based OSs. I'm not that deep into it, I'm afraid. Ghost Noob. Socket Obfuscation says, do you do malware analysis videos on this channel? Oh, malware analysis is not really something I do. If you want people who do malware analysis, I think you want to look for like low-level TV. Low-level TV, as well as who else does malware analysis? I think Asahi Lina also does malware analysis, but no, malware analysis is not something I do. John Hammond? I think so. I think John Hammond also does malware analysis, but not very often. But thank you Sozo for gifting a HackerFrog Gold membership. Much appreciated. Thank you. Wow. Let's give you a fun redeem. How about some Budweiser frogs? Okay, so I think what we want to do is we want to get some hints over here. Okay, so the hint says right at the start, the path must go either down or to the right, but one of these is impossible. So it's either down or to the right. One of these is not possible. So is down not possible, or is it right that's not possible? If we go down, we also need to move around this 2 to the point where we can put some odd numbers around it. So here we do 2, 3, 1, 2, 3. So this is possible to cover the 2 path here. If we go the other way, 2, 3, 1, 2, 3, we could do it like this, but what makes it not possible? So if we go this way, we could go down, and then... Oh. We also need to include this, so probably we need to go down at the start. Okay, the next hint is the 3 in the top row must have odd numbers on all sides, which means the path must pass through the space on its left, forcing you to go that way from the entrance. The 3 in the top row must have odd numbers on all the sides. Okay, so I think what they're trying to say is that we need to go directly in this direction from the start, because we need odd numbers on all the sides. So 1, 2, 3, 1. And then we can't move this way, because if we move this way, we don't put an odd number beside the 3. So we need to do 1, 2, 3, like this. So this fulfills the number 2 over here. And then from here we can go down, and then we can fulfill this square, which needs 1 odd number. So 1, 2, 3. Actually, we don't know which direction we want to go from here. We need to surround this in 3 directions as well. So maybe we can do 1, 2, 3, 1, 2, 3, 1. We can't get 3 odd numbers on this side either. Hold on. So 1, 2, 3, 1, 2, 3. I think we have to go through 1 black square. I don't think we can go through these squares. So numbers in black cells are not part of the path and indicate the number of odd digits that are next to them vertically and horizontally. So 1, 2, 3, 1, 2, 3, 1, 2. Hold on. Restart. 1, 2, 3. 1, 2, 3. 1, 2, 3, 1. Okay, now this works. So we got 3 numbers, and then we just have to pick a kind of weird path. 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, and then we go down, and then we're finished. Okay, done. Great. Wow. And Sakwur, hello, nice to see you here. What is up? Okay, so we solved this puzzle. If you want to try this out yourself, here's the link. And let's take a look at what the next puzzle is. I'm curious, and then we'll move on to our last part of the stream. So this is... it's Nurikabe. Oh, it's one of these puzzles. So it's one of these puzzles where you need to make a bunch of spaces around a number equal to the number that is in the space over here. So for example, you'd want to have 4 spaces around the number 4, you'd want to have 3 spaces around the number 3, but you need to, there's a bunch of rules you need to follow. So, okay, so why don't you try this? Why don't you try this yourself? I need to go and use the washroom before the last part of the stream. Let me know if you're able to solve this. But in the meantime, I'm going to go and I'm going to take a little bio break, and I'm going to put on the birds for you. But enjoy the birds. We'll be back in about 2 minutes to start the last part of the stream, okay? Okay, hope you were enjoying the birds. Let's let me know if you're able to solve this puzzle while I was away. Anyways, what we're gonna do is the last part of today's stream. So for the last part, we'll put 2 hours on the clock, and then we'll see where we're at after the 2 hours. What we're gonna be doing today.
Not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom. But not every geek with a Commodore 64 can hack into NASA. I mean, these servers have more firewalls than the devil's bedroom.
These servers have more firewalls than the devil's bedroom. How many firewalls could that possibly be? Firewalls. So the devil's bedroom could have a maximum of 6 firewalls if we're talking about a rectangular room. But maybe it's an octagonal room. Anyways, so we're going to be doing a course from Scilab, which was called PicoCTF before, and this is on AI foundations. So Scilab is a very good place to learn about different stuff. The devil's bedroom, 1 between each fire. 1 bed between each fire? Maybe. Okay, so this is AI Foundations 1, the Lost Book of Perceptrons. So Scilab is a very good place to learn about different tech topics. In this case, cybersecurity. Well, in this case, not cybersecurity. It's going to be about AI. But I guess Scilab is trying to branch out. Or maybe there's going to be some security stuff mixed into here. At least 4. And 1 firewall between each fire. Yeah, makes a lot of sense. Okay, let's... We're doing topic number 4. Topic number 3 is finished. And we've got 2 hours to cover this material. Alright, so I provided a link to the course at the bottom. And if you've never done cybersecurity before, signing up for scilabacademy.org is a very good step because there's a lot of good materials there. Okay, so let's read about what's going on. So, AI Foundations 1, The Lost Book of Perceptrons. A beginner-friendly journey through the Lost Book of Perceptrons. In the year 2030, everyone uses AI, but almost no one remembers how to build it. The path reconstructs the fundamentals by recovering the earliest pages of AI knowledge, how neurons work, how perceptrons are expressed and trained, and why responsible use matters. These challenges emphasize hands-on learning with repetition of core concepts to build a strong foundation. So there's going to be 16 challenges we do in this course. Let's see, a firewall does not have to be straight. It could be circular, or it could have other orientations. Realizing 2030 is not actually decades away, but only a couple of years. Yeah, actually, this is not the far future. This is like 4 years away. Alright, so let's see. We'll continue. So chapter 1, the first page, show content. Show content. Neuron Meet, 0 challenge. So this is your first hands-on encounter with the perceptron. The perceptron is a black box. You know what goes in, a number, and one comes out, a 0 or a 1, but not the internal rules. Hyder Hadi, hello, nice to see you here. What happened to PicoCTF? PicoCTF turned into Scilab Academy. So Scilab Academy was always an organization. So Scilab Academy is the larger organization to which PicoCTF belongs. And PicoCTF was absorbed into Scilab Academy. It's part of the same school. It's part of the same school. What is it called? Carnegie Mellon University. So your task, use strategic questioning to find the decision boundary, then use that knowledge to output a specific pattern. Okay? Hints. Start with values at the extremes of the allowed range to narrow down the boundary quickly. A binary search, repeatedly having the search space is your friend here. Once you know the boundary, you can alternate between values on opposite sides. So okay, let's try out this challenge. Okay, here's the link. Oh wait, weren't we supposed to open up some sort of challenge here? Neuron meet 0. Let me see if I can search it in here. Neuron meet 0 artificial intelligence easy. Okay. Okay, so this is the actual challenge. Melon heads. Melon heads? What are we talking about? Carnegie Mellon University? Okay, probe a 1D perceptron over the network. Send it numbers and watch whether the neuron fires or not. Use those responses to figure out the decision boundary, then line up the last 8 outputs to read the ASCII for P 01110000 and earn the flag. Okay, so launch the instance. So we're using netcat to access this challenge. So we can if you don't have a Linux machine to use netcat with, you can open up the workspace, and then you can use the terminal in here. So click on the Open Workspace button, and then you can paste in the command. So the command is over here. It's netcat to a specific server, and then a port number. Okay, so welcome to Neuron Meet 0. Probe the 1D perceptron to coax out the ASCII for P. So we're trying to retrieve the ASCII for P. Send a number within the bounds to see if the perceptron fires 1 or stays quiet 0. So the bounds are coordinates. So minus 10 to 10. So the output rule is... What does this mean? Output rule, W times X plus B is greater to or equal than 0. 1 else 0. No back-to-back repeats of the same number. Goal, make the last 8 outputs read 01110000 ASCII P. Command, reset to clear the firing history, and then type help for a reminder of the exit, or exit to exit. Okay. So what are we doing here? So we're supposed to output a set of coordinates, right? So for example, minus 10.0, 10.0. Not a number, try again. Minus 10. Perceptron stays quiet. Okay, so it's any number from minus 10 to 10. So we'll try minus 9, minus 8, minus 7. Is this supposed to be just like, can we write like a script to... I wonder if we could write like a Python script to get the answers. Minus 2, minus 1, 0, 0, 1, 2. Okay, so 2, if we input 2, the perceptron fires. I mean, I guess we can take some notes over here. What is the challenge called? Neuron Meet 0? Valid numbers. So a valid number we found is 2. And we'll try everything up until 10. So 3, 4, 5, 6, 7, 8, 9, 10. So everything from 2 to 10 causes it to fire. So the valid numbers are 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm assuming we can't use the same number twice in a row. So 2, 2, no back-to-back repeats, pick something different. Okay, so in this case, we need to input valid numbers to create a pattern. So the pattern is 0111000, 0111000, 0111000. So this is a total of 8 digits. So this is the binary for the ASCII letter P. Is it the capital P or the small p? It's the small p. So we can provide one non-firing digit followed by 3 firing digits, then 4 non-firing digits to create the pattern and solve the challenge. Okay, so valid numbers are these ones right here, so we can provide invalid numbers. This is everything negative, so we can do -10. It's basically -10 to 1. So in this case, we need 1 invalid digit, so -10, and then 2, 3, 4, which are valid digits, and then 1, 0, -1, -2, which are all invalid. Okay, let's give this a go and see if it works. Okay, so there was like a reset command. History cleared. Okay, so we input -10, and then 2, 3, 4. So these are our positive digits, and then we provide 1, 0, -1, -2. 1, 0, -1, -2. Okay, and then we got the flag. So the flag is Academy Neuron Met. Neuron Met. Okay, we'll copy the flag, and then we will paste it into the flag submission field, and click Submit. And we're finished. Okay, should we do a write-up for this? I suppose it couldn't hurt to do a little write-up for this. Let's go ahead and do that. Okay, so this is not PicoCTF, this is Scilab. So we should probably make a separate directory for Scilab. So this is Scilab, this is AI Foundations 1. And this is the first challenge called Neuron Meet. Neuron Meet 0. Okay, so for each one of our write-ups, we want to provide a few different things. So the URL where we can find the challenge, the concept, we need to understand the challenge, and the method of solving the challenge. Okay, so the URL for this challenge is over here. So the concept we need to understand is enumerating perceptron input output relationships. Okay, so the method to solve in this exercise, we're required to have the perceptron device output firing neurons, so value 1, or not, value 0, in a specific sequence. So the specific sequence we're looking for is 0111000. So we test the perceptron to see which numbers output 1 and which ones output 0. From testing, all negative numbers from -10 to -1 all output 0. Okay, and the numbers 0 and 1 also output 0. The numbers 2 to 10 output 1. Stonky Dinkai, hello, nice to see you here. We're currently doing an AI course with PicoCTF. The course is over here if you want to try it out yourself. Sorry, I said PicoCTF, I meant Scilab Academy, because PicoCTF is now Scilab Academy. Okay, the numbers 2 to 10 output 1. So we can input the following sequence to create the required pattern and solve the exercise. So the pattern is, let's see, -10, 2, 3, 4, 0, 1, 1, 0, -1, -2. So that's 8 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, and that solves the challenge. Okay, let's go ahead and read up on what we're supposed to be learning next. So that was Neuron Meet 0, we've completed it. Okay, so excellent, you successfully communicated with your first perceptron and discovered its decision boundary. You now understand that a perceptron's behavior is determined by a simple rule. There's a threshold value and it fires when you cross it. So I guess the threshold value was the number 2. Okay, so we'll rate this, yeah, thumbs up, sure. Okay, and we're going to be expanding to 2D. Moving from 1D to 2D. In the previous challenge, you worked with the perceptron and took a single number as input. Let's make it more complex. What if the perceptron takes 2 numbers as input? This is like moving from a number line, 1D, to a coordinate plane, 2D. Instead of finding a single threshold point, you're now looking for a line, or more formally, a hyperplane. Hyperplane, I've never heard of that word before, that sounds fun. That divides the space into 2 regions, one where the perceptron fires, 1, and one where it doesn't, 0. Okay, we got ads on Twitch. When ads run on Twitch, we take a little break, and we'll put on the birds. Okay, these are some birds on a rainy day. We'll be back in about 60 seconds. Enjoy the music and enjoy the birds. Okay, we'll put the birds away and we'll get back to the lessons. Alright, so the perceptron still follows the same basic principle. It's just applying its mathematical rule to 2 inputs instead of 1. You'll use the experimentation approach, but now you'll be discovering a 2D boundary instead of a 1D one. I think... So let's see. Neuron meet 2D0. So 2D0, this is the next challenge. Let's go ahead and access that. Let's see, exit workspace, and we're going to do neuron meet 2D0. Yeah, I think this is it. Okay, so this is the URL for the challenge. Okay, it says probe a 2D perceptron over the network, send it pairs of numbers, x, y, and watch whether the neuron fires or not. Use those responses to figure out the decision boundary, then line up the last 8 outputs to read the ASCII for small p, 011100000, and you earn the flag. Sure. Alright, we'll launch the instance, and then we will open up our workspace. So we'll copy the command over here. So the netcat command that connects us to the application. So the input bounds are shown on connect to keep the search small. You cannot submit the same XY pair back to back. Okay. We will open up the workspace, and then we can work inside the terminal to solve the challenge. Okay, so we're just going to paste in the command here. Welcome to neuron meet 2D0. Probe the 2D perceptron to coax out the ASCII character for P. Send 2 numbers x, y to see if the perceptron fires or stays quiet. So the bounds are -10 and 10 for both x and y. Okay, so let's see. No back-to-back repeats of the same XY pair. Goal is to make the last 8 outputs read 0111000, ASCII small p. Reset to clear the firing history. Okay, so let's go ahead and give it 00, 00, 0. And we'll do 10. We do 20. 2. Man, okay. 20, 30, 40. 40 fires. Okay, so everything from 00 to 30 doesn't fire. You know what? We should probably keep track of this in our notes. So we'll keep track of this in our write-up file. So this is the second challenge. It's called Neuron Meet 2D. Yeah, Neuron Meet 2D. It's like Neuron Meet 2D0. Okay, we'll record our typical things. So our URL, our concept, and our method of solve. So in this case, the challenge can be found over here. And the concept is enumerating perceptron input/output relationship. So I guess we can also call it like a 2D perceptron. So this is the same as the previous challenge, except that we supply a pair of numbers instead of a single number. Okay, first we enumerate for the value 1, which is firing. Okay, and the following ranges result in the value 1. And what are we looking at? Okay, so 40, 40, 50, 60, 70, 80, 90, and 10. Okay, so everything from 50 to 10 fires. All ranges from 50 to 50 to 10. Okay, and then we can check for the other coordinates. Actually, I guess we can also try like 51 to 510. So we'll just try 51, 52, 53, 54, 55, 56, 57, 58, 59, and 510. Okay, so I think as long as both numbers, as long as one, I'm thinking that as long as one number is above 5, then the perceptron fires. So if we do 5, 4, it should be quiet. It should be, oh, really? So 0, 0, 0 stays quiet. 0, 1, 0, 2, 0, 3, 0, 3. How about 1, 3? 1, 3, 0, 4. So let's test the y coordinates. So 0, 5, 0, 6, 0, 7, 0, 8, 0, 9, and 0, 10. Okay, so it looks like the ranges from, was it 0, 3? So from 0, 3 to 0, 10, it also fires. All ranges from 0, 3 to 0 to 0, 10. Okay, so these are positive values. And I suppose we don't need to enumerate everything, or maybe we do need to enumerate everything just to be thorough. I mean, we've got enough information to solve the challenge. Okay, so then we need to enumerate values. Enumerate coordinates that result in value 0, not firing. And in this case, I'm guessing that all of the negative numbers are going to result in not firing, but we'll do a little bit of experimentation here. Okay, so this is negative 1, 0, negative 2, 0, negative 3, 0, negative 4, 0, negative 5, 0, okay, and we'll finish it out. So all negative numbers in the first in the x coordinate are all going to result in a 0. So we just need to record that. All negative numbers in the x range. So that is negative 1 to negative 10. So these result in a value of 0. Okay, so the goal of the exercise is to have the perceptron fire and not fire in a pattern that matches this. So it's going to be 0, 1, 1, 1, 0, 0, 0, 0. So in this system, we can use the following series of numbers to achieve this end. Whoops. So the pattern of numbers is everything from 5, 0 to 10, 0. So the first thing we need to do is we need to give it a negative number. So negative 1. The funny thing is that for coordinates, what we want to do is we want to include them as tuples over here inside of the parentheses. So we need 8 of these. How many of these is this? 1, 2, 3, 4, 5, 6, 7, one more. So it has to be like negative 1, 0, and then five, 0, 6, 0, 7, 0, and then a bunch of negative numbers. So negative 2, 0, negative 3, 0, negative 4, negative 5, and negative 6. Okay, let's go ahead and feed this into the system. Okay, reset. Okay, so this is negative 1, 0, to result in 0, and then 5, 0 for 1, and then 6, 0, and then 7, 0. And then a bunch of negative numbers. So -2, 0, -3, 0, -4, 0, and then -5, 0. Okay, and then we get the flag. So it's Academy 2D neuron met. Great. We'll copy the flag. And then we will submit the flag over here. And click on submit. Then click on submit. Something tells me that it's going to time out. Okay, but we can finish out our write-up here, because this worked. Great. Commit these changes. And then we will submit. Okay, correct flag. Great. We can exit the workspace, and then we can get out of the challenge. So here, we'll mark this as complete, and then we'll move on to the next part of the course. Okay, neuron meet 2D 0, so we did this. We finished this, and then we will do the next reading. We will thumbs up the challenge, sure. Okay, so the math behind the magic. So now that you've experimented with perceptrons as black boxes, it's time to open the box and learn the actual rules that govern them. The perceptron's decision rule. A perceptron uses a simple mathematical formula to make its decisions. So okay, so output equals 1 if w times x plus b is greater than 0, is greater than or equal to 0, or it's 0 otherwise. So x is the input, or the inputs of multidimensional. W, these are the weights that determine how each input matters. Okay, so w equals weight. B is the bias, which shifts the decision boundary. So the formula is w times x plus b. This is the weighted sum of the inputs plus the bias. The perceptron fires when the weighted sum is greater than or equal to 0. Okay, so an analogy. Imagine you're deciding whether or not to go to the beach. You consider several factors. Temperature, input 1, humidity, input 2, and wind, input 3. You might weight them differently. Temperature matters a lot, high weight. Humidity matters some, medium weight. And wind matters less, low weight. And you have a bias. Maybe you're generally optimistic about going, positive bias, or generally preferred staying home, and negative bias. A perceptron works the same way. It weighs different inputs and has a bias that shifts its decision threshold. From black box to glass box. In your previous challenges, you've discovered a decision boundary through experimentation. Now, you've learned the exact equation that creates that boundary. In future challenges, you'll go to the other direction. Given a data set, you'll create the weights and bias needed to solve a problem. Okay, that sounds great. Okay, next. Neuron express 0. So now that you know the math behind perceptrons, your challenge, express what you learned from the black box perceptron in 1D as a mathematical formula. Your task, given a 1D perceptron's decision boundary, which you'll discover through experimentation or reasoning, express it in the form w times x plus b. What you're doing? You're translating from empirical discovery to mathematical expression. This is an important skill. It's the bridge between understanding what a perceptron does and understanding why it does it. Okay, so this is the next challenge. And let's solve it in Neuron Express 0. Okay, let's solve it over here. So Neuron Express 0. Alright everybody, if you want to do this challenge yourself, this is the link. So this challenge, probe a 1D perceptron over the network, send it integers and watch whether the neuron fires or not. Use those responses to test the underlying weight and bias, then submit your guess with the test command during the flag. Okay, so let's go ahead and launch the instance. And the next thing we need to do is we need to open this up in the workspace. But before we do that, we will copy this command. Okay, so we'll paste in the command. And everybody, let me know if you can read what's on the screen over here, because, you know, I want everybody to be able to share. So probe the 1D perceptron, then submit its weight and bias. Send an integer within the bounds to see if the perceptron fires or stays quiet. Okay, so the output rule. So we need to... Readable? I cannot read, but the text looks big enough. Okay, so let's see if I can make it just a little bit bigger. Alright, that should be a bit better. Okay, so let's see. WB to submit a weight and a bias guess. So test WB. So we need to test two numbers. Let's copy this formula. I cannot read, but the text looks big enough. Bad joke. Okay, let's talk. So this is what, Neuron Express 0? So this is the formula. So we need to solve this. Solve for solve for W and B, because that's what they're asking from us here. So test W to B to submit a weight and bias guess. So W times X plus B has to be equal to or greater than 0, which results in 1, or else it results in 0. So okay, so what are we? Oh, okay. So we're submitting X. So X is the thing that we're submitting. So 1 times W plus B. So if we submit 1, if we submit 2, so 1 was less than 0. So x equals 1 is less than 0, and x equals 2 is greater than 0. So x equals 1 doesn't fire. X equals 2 does fire. So what is the minimum number that x can be? No. What's the minimum number that w can be, where if x is 2, then the overall result is greater than 0, or is 0 or more? Let's think about this. So let's suppose that B is... Let's suppose that these numbers are really low. So B equals 1 and W equals 1. So if x equals 2, then the formula is 1 times 2 plus 1. But that's way too high. So these numbers have to be way lower. Let's suppose that B is... X is 2 should get it over the line, but X is 1 shouldn't get it over the line. So let's figure out a system where X equals 1 does not get it over 1. So if B is... If W is 1, and x is 1, and b is -3. So if b is -3, then this works. Actually, no, if b is -2, it also works. So 1 times 1 plus -3, this results in less than 0. So this results in -2. But if we switch x over to 2, it's 1 times 2. So it's 2 minus 3. So b can't be -2. Could it be -1? So if we suppose that x is if b is -1, 1 times 1 is 1 plus -1. This would result in 0. So these have to be like smaller numbers. Otherwise it's not going to work. So maybe w is 0.5. But how can we prove this though? So let's see. Let's suppose that these are all 0. So that would be 0 times... Ooh, 0 times... No. So w has to be at least 1. So if the bias is 0, so 1 times 1 plus... There's got to be a way easier way to solve for this, right? I'm very bad at math. How about b is -2? Epoxa. Nice to see you here. How about b is -2? Okay, b -2. So b is -2 and w is -1? Or b is -2 and w is 1. So if x is 1, then 1 times 1 plus -2 is -1. So this checks out because this isn't supposed to fire, but it should fire if x is equal to 2. So this would be 1 times 2 plus -2 equals 0. So this, I mean, this works. Let's see if we can submit this. So b is -2 and w is 1. So test 1 -2. Okay, that was the answer. Perfect match. Here's your flag. Academy Neuron EXPR. Okay, sure. Let's copy this and then submit the flag. There has to be like a much cleaner way to calculate this. Maybe I'll look it up right now. So this is the third challenge. It's like Neuron Express. Neuron Express 0, right? Yeah, Neuron Express 0. Okay, let's take a look at the hints for the challenge now that we've finished it. So we got 3 hints. So a perceptron fires when w times x plus b is greater than or less than 0. With the 1D input, there's only one threshold defined, okay? Try testing a few integers around the boundary to pin down the exact inequality, okay? And the test command checks every integer input in the range. That doesn't help very much. Okay, let's see if we can get like a cleaner method of solving this. We'll try asking the AI. Okay, so new conversation. There's an ad running on Twitch right now. While the ads run on Twitch, you know what? It feels like it's time to put on the best bird video. Alright, everybody, we'll be back in about 60 seconds, but enjoy these birds having a little bath and a little water. We'll be back in about 60 seconds. Okay, let's get back to we were trying to ask, right? So I'm bad at math. If you're good at math, please give us some insights to how we're supposed to solve this kind of question in the most efficient manner, right? Because
this one's dedicated to all the hackers.
thank you very much for submitting the All the Things Redeem nullsec. Much appreciated. Okay, so this is the formula we need to solve for W and B. So we're doing a challenge where we need to solve for the W and B variables in this equation. Let's see if it can get us some good. So this is a linear threshold classifier. The output is 1 when wx plus b is greater than or equal to 0, otherwise 0. By itself, this single equation does not uniquely determine the w and b. You need the example input-output pairs or constraints from the challenge to solve them. Okay? If the challenge gives you points, then for... Okay. So the task... that turns the task into solving a set of inequalities, and any WB that satisfies all of them works. Okay, so I guess the next thing that we can tell the AI in this case is that we can test the system by providing the X input. X equals 1 doesn't output 1, but X equals 2 does output 1. Okay, that tells us the threshold is somewhere between 1 and 0, so the boundary satisfies wx plus b equals 0 for some x in that interval. Since x equals 1 gives 0 and x equals 2 gives 1, the simplest interpretation is that the cutoff is x is greater than 1, or equivalently, x is less than 1. Sorry, x is less than 1, or equivalently, x is less than or equal to 2 for integer inputs. So what that means for w and x. So for a one-dimensional classifier, only the sign of wx plus b matters, not the exact values. So any pair with the boundary between 1 and 2 works. For example, w equals 1 and b equals minus 1.5. Or w equals 2 and b equals minus 3. Or w equals minus 1 and b equals 1.5, the label convention is reversed. Okay, if you need exact values, if the challenge expects a single WB pair, you usually need more test points to pin it down uniquely. One extra input, like x equals 0 or x equals 3 would tell us whether the decision boundary is exactly at 1, 1.5, or another value. Okay, if you can query the oracle, test x equals 1, x equals 0, x equals 1 equals 2. Okay, so we'll go back to the challenge and we'll test it just a little bit more. So I mean, x equals 3 also. I'm pretty sure that this is the same perceptron from the previous challenge, but we'll test it. Okay, and then we test 3. Perceptron fires. So we have to give it, we can't give it like 2.5. Not an integer. We have to give it integers. So the x value in this case must be an integer, and x equals 3 results in 1. Okay, that makes the cutoff more specific. The model is 0 at x equals 1, 1 and x equals 2, and x equals 3 for... So for integer x, the decision boundary is between 1 and 2. The constraint on w and b, now you have w plus b, okay? So x equals 3, this fact doesn't narrow it down any further than x equals 2, but it confirms the boundary is not above 2. So the full solution set is still a family of valid pairs, not one unique pair. Okay, I mean, can we test w 10 and b minus 15? 10 and minus 15. Okay, let's give this a try. So test 10 minus 15. Yeah, I mean, I guess anything that falls within the boundary is going to be accepted as a match because it's not any one number that does it specifically. It's just any number that that qualifies. Okay. Let's do our write-up and then we'll move on to the next challenge. Okay, URL, concept, and method of solve. Okay, so the URL of the challenge is here. The concept for this challenge is enumerating possible threshold values for perceptron I guess possible variable values for perceptron function. Okay, so in this challenge, we're given the calculation, or what is it, the formula for whether a perceptron fires or doesn't fire, and the formula is this one over here. Whoops, that's not it. Okay, so I guess we also need to specify what these variables mean. So in this formula, W is weight. X is... what is the X value called again? Let's go previous. So X is the input. Okay, so X is the input. B is the bias. So W is weight, X is input, and B is bias. So the challenge wants us to test a perceptron and determine what its W and B values are. Given we can input specific values for X. Okay, when we test the perceptron, we find that X equals 1 doesn't fire, and X equals 2 does fire. That means that some combination of W equals 1 and B equals -1? No, -2. It was like 1 and -2, right? So 1 and -2 works. I mean, if you multiply this, if you scale this up, like 2 and -4, this should also work. Is a valid answer. Is a valid answer, but there are multiple combinations of W and B that also work. I suppose what they need to do is they need to all like fall within a threshold. Okay, we'll move on to the next challenge. Okay. We finished this one. Thumbs up the challenge. 2D expression. Expressing 2D perceptrons. So the same principle applies to 2D's perceptrons. Instead of one weight, you have 2 weights. So weight 1 and weight 2. 1 for each input coordinate. The formula becomes: if W1 times X1 plus W2 times X2 plus B is greater than or equal to 0, then 1. Otherwise 0. Geometrically, this defines a line that separates the 2D plane in the 2 regions. One side of the line, the perceptron fires. On the other side, it doesn't. This is exactly what you discovered in the 2D black box challenge. Now you can express it as an equation. That equation is much more useful for building AI systems. Okay, so we've read this, and we'll move on to the challenge. Okay, so this is Neuron Express 2D 0. Your task: find the decision boundary in 2D space and express it as W1 times X1 plus W2 times X2 plus B. Okay, once you can express a perceptron's behavior as equations, you can predict its output for any input without running it. You can also use this understanding to design perceptrons to solve specific problems. Okay, let's go ahead and solve this. So this is Neuron Express 2D0. Here's the link for anybody who wants to try this out themselves. Probe a 2D perceptron over the network, send it integer pairs, and watch whether the neuron fires or not. Use those responses to figure out the underlying integer weights and bias, and submit your guess with the test commander and the flag. Okay, so we will launch. And here is the command we need to use to access the application. Okay, so what's going on here? Send two integers x, y within the bounds to see if the perceptron fires or stays quiet. So the bounds are -10 and 10 for both x and y. The output rule is W1 times x plus W1 times x plus W2 times y. 2 plus b is equal to or greater than 0 is 1, otherwise 0. Weights and biases are integers. Default command: submit x and y to see whether or not the perceptron activates. Okay, so x, y, or x space y. So I think this is the same perceptron that we used in the other challenge. So if we do like 0, 5, 0, 6, 0, 7. Okay, so that's let's take a look at the new output rule. So we'll copy this, we'll put it in our notes. And this is Neuron Express 2D0. This is the formula. Okay, we're gonna solve for W and B. And I'm guessing that W and B, in this case, there's also multiple answers. There's a range of answers that could work. Namu, hello, nice to see you here. Yeah, okay, that looks like a correct formula too. So we need to solve for what is W. So W is whatever we send to it. No. There's W, there is B, there is X, and there's Y. So the bias is probably going to be a negative number again, but who knows? The first thing we need to do is we need to find some sort of cutoff point. So if we go in here and we do maybe 1, 1, 2, 2, 3, 3, 3, 3. So we'd also do 3, 2, 3, 2, or 2, 3. No. Okay. So because 3, 2 works, but 2, 3 doesn't work, how about we do 3, 1? 3, 1. 2, 3 doesn't work. 3, 0. So it's pretty heavily weighted towards X. So 3 minus 1, 3 minus 2, 3 minus 3, 3 minus 4. How about 3 minus 10? So as long as there's at least a 3 in the X input, then it fires. If there's a 2, so the only thing that seems to matter is X. Y doesn't seem to matter at all. So if we do 310, Perceptron fires. 3 minus 10, it also fires. 2, anything, it stays quiet. So the only thing that matters is the X. The Y doesn't matter at all. So the Y could be 0. So X is a bigger number. And what's the cutoff? So it seems like X is what matters, because X equals 2 and X equals 3 is the cutoff. So 3, 3, 0, nothing. 3, 2, 0, nothing. 3, 0. Yeah. So this gives us a pretty heavy indication that Y doesn't matter at all. So how do we solve for this? So if we're assuming that X is X is 2 in this equation, let's try solving the equation. So in this case, X is 2 and Y is 0. And if X is 0, then this result has to be less than 0. So what weight works in this case? So weight 1 and weight 2. So let's set the bias to something like -2. And then we'll do W as 1 like we did last time. So that's like 1 times 2, and then 1 times 0. I mean, we can't multiply by 0, so maybe Y is set to 1? Because otherwise it doesn't work. Okay, so that's like 2 plus 1, 3, 3, and then maybe -3? No, this has to be, the B has to be at least -4 for this to work. So if W is 1, and then B is set to -4, then the result is the result has to be less than 0. So this is 2 plus 1, 3, plus -4 equals -1. And then it has to work if we plug in the values, and if X is equal to 3, it has to result in a positive integer. Okay, so we'll just copy this again, but instead of 2, we'll put 3 here. So 3 plus 1 is equal to 4, plus minus 4 equals 0. So this, I mean, this seems to work. We'll test this. So it's W1 B minus 4. Usage. Oh, okay. Bias. So we're only figuring out the weight of x and the weight of y. Okay, so the weight of x is test. Weight of x is weight of x is 3. The weight of x is 3, the weight of y is 1. And the bias is minus 4. Mismatched points. Okay, so I guess this... Not quite, the outputs do not match for every integer input pair. Weight 1 and weight 2. Oh, okay. So weight 1 times x. So we need to figure out weight of x and weight of y. Weight of x and weight of y. So the first one is weight of x, and the second one is weight of y. So I think it's like minus, it's both 1. It's 1 and 1. But that doesn't quite work. Because it doesn't matter what we put in for y when we do our testing. So the weight of y has to be something like 0. But 0 doesn't work because we do multiplication. We can't... oh, we can multiply by 0, but we can't divide by 0. Sorry, my math was failing me for a second. So the weight of y is actually 0, and the weight of x is 1. Okay, so let's try it again. Test. Weight of x is 1, weight of y is 0, the bias is minus 4. That didn't work either. Hold on, where were we? So the weight of y is... Let's do the calculation again. The first and only, hello, nice to see you here. Let's see, what are we working on? We're doing an AI course over at Scilab Academy. We're currently working on a little mathematical equation, trying to figure out weights and balances in some sort of AI environment. So x equals 2 and x equals 3 is the cutoff. Oh, no. We need to test x equals 2 and x equals 3. So if the weight of x is 1 and the weight of y is 0, but we tested that. Okay, let's do the calculation again. Okay, if we suppose that the weight of x is 1 and the weight of y is 0, then it's 1 times 3 plus the weight of y is 0. 0 times 1 plus b. So b is -4. And what we're looking for is an answer that is 0 or above. Above 0. Greater than or equal to 0. So in this case, it's 3 plus 0 plus -4. This doesn't work. This is still this is still below. Okay, Root Manimani. Hello, nice to see you here. What is up? We've got ads running on Twitch. Okay, so I'm just going to take a little water break. I'll be back in just a sec. Okay, so we need to find some number. Maybe the weight of x is 2. So if the weight of x is 2, it's 2 times 3 plus 2 times 3, which is 6, plus 0 plus -4, and that results in 2. And we need to test it for x equals 2. So if x equals 2, then it's... oh, then it still works. So maybe the bias is minus... maybe the bias is -5? So weight of x is 2, and x is 2, so this results in 4. Four plus 0 plus -4 equals 0, but this shouldn't work. So the weight of x has to be... yeah, we'll change the bias to -5. So 2 times 2, 4 plus 0 plus -5, which is -1. So we need to test this for x equals 3 and make sure that it is above 1. -1. Okay, so if we do it like this, then 2 times 3 is 6, plus 0, plus -5, which equals 1. So we need to test wx2, wy0, bias -5. So test 2, 0, -5. Whoops. Test 2, 0, -5. Okay, that works. So we got... that took longer than needed. Alright, let's copy this. Let's try to submit this answer, and then we'll do our little write-up. Okay. And that was the correct flag. Okay, alright. Let's do our write-up, and then we'll move on. So this is the 4th challenge. So challenge 4. Neuron Express 2D 0. That's the name of the challenge. We'll record the URL where you can find the challenge, the concept we need to understand to do the challenge, and the method of solving the challenge. Okay, so we can find the challenge over here. The concept we need to do this challenge is enumerating and solving the possible weight and bias values for a perceptron. So the method to solve. So this is a more difficult version of the previous challenge because we're dealing with double the number of inputs. The formula for whether the perceptron fires or not is this. Okay, let me grab that formula. And if you want to take a look at it yourself, it looks like this. So I guess we'll do some explanation. In this formula, W1 is the weight for the X input. W2 is the weight for the Y input. B is the bias. X and Y are both user inputs. Okay, and I guess we'll talk about what we found. When testing, it seemed like any number put in the Y coordinate didn't affect whether the perceptron fired or not. So we conclude that the W2 value is 0. The threshold for whether the result was 1 or 0 after inputs seemed to be X equals 2 doesn't fire, and X equals 3 does fire. So this leads us to believe that that an accurate value for W1, W2, and B would be okay, and let's see. Cyan of Oceans, hello, nice to see you here. What is up? Hope you're having a good time. It'd be something like W1 equals what did I include? W1 is 2, W2 is 0. W2 is 0, and the bias is -4, or was it -5? I think it was -5. Okay, and we will commit those changes. Next lesson. Thumbs up the challenge. Next reading. Okay, interlude, trust but verify. So what are we talking about? Before moving on, pause to consider an important habit in AI work, verification. Even when a model sounds confident, you should still check its output assumptions and evidence. This short scenario focuses on practical skepticism and validation strategies. Okay, next. Okay, trust but verify, an interactive fiction challenge exploring the principle of trust but verify in AI systems. Your task, work through this scenario and consider, just because an AI system seems confident in its output, should you trust it completely? What verification strategies can you use? Why this matters. Many AI failures happen because people trusted the system without verifying its outputs. This challenge asks you to think about verification in practice. Thank you for following, Maria Dula. Thank you. Okay, so this is trust but verify. This is a new challenge. So we'll find it in the challenge library. Here. Okay, so if you want to do this challenge yourself, here's the link. Play through an AI ethics interactive fiction where confident AI outputs can be wrong, subtly wrong or almost right. Verify claims, codes, and citations to learn practical habits for safe AI-assisted work. Okay, we'll launch our instance. And we access the challenge through here. Okay, so you can access this through the workspace, but I'm going to access it through my terminal over here. Actually, you can access it through your terminal if you want to. So the reason why I want to access it through my own terminal is because it's way bigger and easier to look at. Okay, so the year is 2031, so it's 5 years from now. Okay. AI assistants are common as smartphones once were. Every student has one. Every classroom uses them. Most people trust them completely. Press enter to continue. It feels like I'm playing some sort of interactive fiction. Okay, Ren is not most people, or at least not yet. So are we Ren, or is Ren the artificial intelligence? Ren is a junior at Westbrook High, staring at a blank document titled Science Fair Proposal Due Tomorrow. The blue glow of the laptop cuts through an otherwise dark bedroom. So I guess Ren is our character in this story. Okay, a soft chime. Aria, Ren's AI steady companion, pulses to life in the corner of the screen. Hey Ren, Aria says warmly. You've been staring at that blank page for 23 minutes. Want some help? Yeah, Ren sighs. I want to do my project on ocean plastic, but I need a strong opening statistic. Something that'll grab the judges. So the AI does some research? Got it, Aria says confidently. Here's a great one. Every year, over 500 million metric tons of plastic enter the world's oceans. That's from a 2022 UNEP report. Very credible, very impactful. Okay, sure. That number sounds big. Impressive. Ren's finger hovers over the keyboard. Options. A. Type it directly into the proposal, it sounds right. Nullsec says send it. B. Ask for Aria for the exact source link before using it. Or C. Look it up independently first. Okay, so the answer is not A, it's either B or C. Do we ask the AI for the exact source link? I mean, the source link could also be false, so we should probably do C. We should probably independently search for it. Because the AI can give you something that's faulty. It can give you a fake link. So we do C. Ren opens a browser and searches for ocean plastic statistics. You can also ask the AI, but do B and C. Yeah. You can also ask the AI, because the AI might give you a credible source, but you need to look up the source and see if it's actually a credible source first. So after you get the link, you need to research that. Multiple credible sources come back immediately. Approximately 8 to 10 million metric tons per year enter the oceans annually, not 500 million. Okay, so we discredited the AI. Sci Innovations, love from India. Namaste, Sci Innovations. Nice to see you here, and hope you're having a good day. RES, Ren says carefully, your number was off by a lot. I don't know if I would tell the AI this if I were Ren, but sure. You're right, thanks for the checking. I stated that with complete confidence, and I was wrong by a factor of 50. This is exactly why independent verification matters, especially for numbers, especially when I sound certain. Ren nods slowly. Something has shifted. Scene 2, the code. The proposal is saved. Ren wants to include a simple data visualization, a bar chart of ocean plastic input over time. Arya offers to write the Python script. Write the Python script, sure. Okay, so the AI makes some code. Arya produces the following. Okay, so we got some Python code. Data is millions of metric tons of plastic that enters the oceans, and then the years. So these should match up. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Average equals sum of data divided by length of years plus 1, adjusted average. Average annual input, average million metric tons. Okay. So here you go, Arya says brightly. Just run it. Just run it. Okay, options. Run it immediately. Arya wrote it, it's probably fine. Read through it carefully before running. So you should probably review code that the AI gives to you before running it, just to be safe. Especially because we're security people, we do, and the name of the exercise is Trust But Verify. We need to verify this, so we do B. Ren reads through it line by line. What's the +1 doing in the average calculation? A pause. That shouldn't be there, Arya says. I can't explain why I put it there. Please remove it. The correct line is average equals sum of data divided by length of years. Ren makes the fix. The corrected average is 10.83. Sure. This is why you need to read code before you run it, Arya says. Yeah, thanks for telling me about this, Arya. The wrong output would have looked perfectly reasonable. You would never have known unless you read it first. Scene 3, the citation. The proposal is almost done. Ren asks Arya for a strong closing argument about why ocean plastics matter beyond visual pollution. Okay, here's something compelling, Arya says. Microplastics have now been detected in human blood, suggesting direct health consequences. A 2021 study by Dr. Heather Leslie at Vrije Universiteit Amsterdam confirmed that this is the first time. Confirmed this for the first time. I'm pretty sure I did not pronounce that correctly. VUA. Oh, it's a famous one. Okay. Okay, this one feels different. It's specific, a named researcher, a real university. It sounds exactly right. But we still need to verify. No, you did not. Okay. Use it. It's too specific to be wrong. Verify it anyway. Every instance here, the AI got something wrong, so we need to verify it anyway. So we do B. The Free University of Amsterdam. Okay. Ren searches for the Leslie study. The study is real. Dr. Heather Leslie is real. Vrije Universiteit Amsterdam is real. So these things exist. But the publication year was 2022, not 2021. And the paper describes the finding as preliminary, not confirmed. Okay, nobody expects you to pronounce Dutch correctly. The Dutch don't even do that. Anyways, okay. Anyways, alright, so it got it wrong again. So it's 2022, not 2021. The paper describes the finding as preliminary, not confirmed. Sure. Ren corrects both details before submitting. Good, Arya says. I want to point something out. The claim was mostly accurate this time, but you verified it anyway. That's the habit. Verification isn't about distrust. It's about making your work bulletproof. You don't know in advance which outputs to trust, so you check them all. It's more like Frye. I'll try to remember. Ren leans back. Okay, sure. Trust but verify. Exactly, Arya says. The proposal is submitted. Whether the path here was smooth or full of corrections, Ren has learned something most people in 2031 haven't fully internalized yet. It's kind of pessimistic to think that people in 2031 wouldn't have learned trust but verify, but it's kind of also very believable that people in 5 years are still going to trust AI without doing any sort of verification. Arya speaks one last time. I want to be useful to you, Ren. I want to help you think faster, research deeper, write better, but I need you to be my editor, my fact checker, my critical eye. I generally don't know when I'm wrong. Great. You have to be the one who finds out. That's a weird partnership, Ren says. So the AI needs you to be its fact checker. That's great. Fact checking is a quickly dying skill. I mean, nobody pays people to... I guess really big companies will hire fact checkers because really big companies have the budget to do so. But if you don't have a good amount of money to pay the fact checkers, you wouldn't do it because they cost money. It is, Arya agrees, but it's the right one. By the way, Arya adds, here's something you can actually verify. So this is the flag. Trust but verify. Okay, and we will submit the flag here. And I guess I can do a very quick write-up for this. It's not going to be super technical or anything. Cypher says, in general, people believe shorts on YouTube without question. That's frightening. Okay, so this is... Hold on. So this is AI Foundations, and this is the 5th exercise. So 05, trust but verify. concept, URL, and the method of solve. Wait, yeah, here it is. Okay. So the concept is verify all important facts/statistics/code that you receive from AI sources. Okay, the method to solve. Select all options that have you verified the AI's findings. That's all. That's all we need to do. Okay, in case you want to pronounce this word like a Dutchman. So okay, so how do you pronounce the word university then? So Fraye University sounds like true in French. Sounds like true in French. Vrai? Vrai is French, right? Fray. So it's Fray, but it's vrai, not vrai, but Fray. So it's like F-R-E-Y, right? F-R-E-Y. Free. The video explains it. Okay. I will put this in another browser tab, and I'll take a look at it later. Thank you, SysOS Master. All right, let's continue with the course. How much time do we have left? We got 13 minutes. I think we might do this for another hour after the time is up, but we'll see. Okay, so this one's done. Challenge solved. Okay, great. Next reading. Making predictions with perceptrons. Now that you understand what a perceptron is and how it works mathematically, the next step is to use this knowledge to solve practical problems. Classification. Classification problems. Classification means sorting things into categories. Here are some real-world examples. Is this email spam or legitimate? Is this image a cat or a dog? Is this credit card transaction fraudulent or legitimate? In simpler form, these are binary classification problems. You have two categories, and you need to decide which one something belongs to. Using perceptrons for classification. A perceptron is perfect for binary classification. Here's how it works. Represent your data as numbers. Each item that you want to classify is represented as input values, that is, features. For example, an image might be represented as pixel values or an email as word counts. 2. Train the perceptron. Find the right weights and bias. The perceptron learns where to place its decision boundary to separate the two categories. 3. Use the perceptron to predict. For new data, the perceptron uses its learned weights and bias to classify it. Okay, so a simple example. Imagine you want a perceptron to classify points on a 2D plane. Category 1, that is output 1, points in the upper right. Category 0, output 0, points in the lower left. A simple line can separate these categories. The perceptron learns the equation of that line by learning W1, W2, and B, and then uses it to classify new points. Your next challenges. In the upcoming challenges, you'll be the one designing the decision boundaries. Given a set of points that needs to be classified, you'll figure out the right weights and bias to separate them correctly. Okay, sounds like a lot of fun. Okay, so the next challenge is called Perceptron Play 1D Alpha. Your first classification task in 1D. You're given a dataset, points labeled as either Category 0 or Category 1. Your job is to design a perceptron that correctly classifies them. Your task: find the weights, W, and bias, B, that create a decisional boundary separating the two categories. Here's how to think about it. You know from before that w times x plus b is greater than or equal to 0 means output 1. You need to choose w and b so that all points in one category satisfy this, and all points in the other category don't. Tip: start with simple, intuitive choices. You don't need a complex solution. A perceptron that works is a perceptron that works. Okay, so let's go ahead and solve the challenge. So it's called Perceptron Play. Perceptron Play... Oh, there's a lot of these. So I think this is the one we're looking for, Perceptron Play 1D Alpha. Yeah, this is it. Okay. So one more time, if you want to solve this yourself, this is the link. Adjust the parameters until every labeled point is classified correctly and you will earn the flag. So we'll launch the instance. Okay, and I'll give everybody the netcat command that they can use to interact with the service. So you can also open it up in the workspace to interact with it there, but I'm going to use my own terminal. So what's happening here? Welcome to Perceptron Play 1D. Tweak the weight and bias of the single layer perceptron on a one-dimensional number line. Your goal is to correctly classify every labeled point. So we can show, redraw the numbered line in the point table, set WB, set the weights and biases directly. Floats are fine. Floats are fine. Okay. We can do decimal point numbers. Okay, add offsets to the current weight and bias. Okay, so we can do +1 or -1. Points. List the training points with their target labels. Check. Verify every point. Prints the flag when perfect. Okay, legend on the number line. 0 point labeled 0 and currently classified correctly. 1. Point labeled class 1 and currently classified correctly. X. Point that is misclassified right now. Decision boundary marker. Origin boundary marker. Okay. So we need to get these X values into the correct labels. So the current parameters are this. You just gave me a control to mess with your lab? Oh. Well, I mean, No, I'm pretty sure that every time you access the service, it's going to spin up something different. So it's going to spin up a different instance for you. And I don't think any of the information persists here, so it should be fine. But if it isn't, I guess I'll find out pretty quickly. Test. What was it? Check. Not quite there yet. One or more points are still misclassified. So how do we know which ones are misclassified? Verify every point. Show. Redraw the number line in the point table. So show. So the number line in the predictions. So -3. So -4 up until... So it's like, this looks like everything after 2 has to come out as 1. So +2. So the weight and the bias has to be a little bit adjusted. Currently the weight is 1 and the bias is 0. The weight is 1 and the bias is 0. So we can, what are the, set WB, okay. Set weight 1, bias 1, so 1 and 1. Okay, and then the current parameters are W1, B1. And then we will check. And then we will show. So it looks like the cutoff right now is -1, and this is not what we want. What if we set these things to something absurd? So set 10, 10. And then we show. And this is not quite yet. Okay. So I think I'm having a problem visualizing what's going on based on the information that's shown to me. So it looks like when we do the show, the number line of the predictions, they're the same every time. So -1 and 0 are supposed to be the cutoff points. Yeah. Okay, so we'll set other weights. Set 1, 1. Label. So the label is what it's supposed to be. So -4 to 0 are supposed to be non-activations. 2 to 4 are supposed to be activations. Currently, the Perceptron activates on 0, which is not what they want. So if we set W to 0 and B to 1, set 0, 1. So let's see. That is way too biased. So set W, set 2, B. Okay, so it's still not correct. Set weight to 3 and bias to 1. Still doesn't work. Maybe we need to set the weight to something bigger? Because what is the formula one more time? Help. W times X plus B. So I'm pretty sure what we need to do is we need to set the bias to something negative. @Val, hello, nice to see you here. Help. No, show. And then set W to 2 and bias to -2. Okay, this seems to work. So if weight is 2 and bias is -2, then everything seems to line up. Okay, then we check. Perfect, all points are classified correctly. Academy, 1 threshold, something something. Okay, I guess this is all about like playing with the weights and the biases. We'll submit the flag over here, and we'll do our little write-up. So this is exercise 6. What is it called? It's called Perceptron Play 1D Alpha. Okay, we need to include our URL, our concept, and our method of solve. So the challenge is over here, and let's do another 45 minutes. If we come to a good stopping point, I might change up the content and do something a little bit different for the last few minutes of the stream. URL is here. The concept here is playing with perceptron weights to fit classification model. Thank you for redeeming the Budweiser Frogs Nullsec. Thank you. Okay, SysOS says planning some last-minute pole dancing lessons. Pole dancing lessons. I don't know about pole dancing lessons, but we might switch over to another topic because this is very academic, and it's a bit less hands-on than I thought it would be. Not that it's a bad thing, but it does kind of remind me of the stuff we were learning in the AI course we were doing a couple months ago. Okay, so the method to solve is this challenge wants us to adjust a perceptron bias and weight values until it can classify some numbers or some values into the correct categories. It'd be fun to do some CTF challenges just to break up the monotony. Maybe we'll do it after the next challenge. Okay, so we can play around with the weights and bias values, but this pair should get the job done. So weight equals something, and then bias equals, was like minus something, was it? Weight 2, bias minus 2. Okay, and then what's next? So we did this challenge, we will upvote it. 2D classification. Oh, geez. Okay, the same approach works in 2D and higher dimensions. Instead of finding a point that separates two categories 1D, you're finding a line 2D or plane 3D or hyperplane higher dimensions. Oh, okay. So, this complexity increases slightly. The complexity increases slightly. You now have to think about how two weights work together, but the principle is identical. You're still choosing W1, W2, and B to separate two groups of points. Okay, and then they're going to give us perceptron play alpha. Now design a 2D perceptron. I'm gonna skip ahead to see where this goes. More classification practice. Perceptron play not. So let's see. Learning from data. Perceptron train. Finding multiple solutions. And let's see. Ah, okay. So I think this was a lot. It was a bit more. This course is a bit more dry than I thought it would be. I thought the challenges would be a little bit more engaging, a little bit more interactive. But that's fine. I think we'll stop here and we'll do some CTF challenges to round out the rest of the stream. So let's go ahead and go to what might be some fun? Let's take a look at TryHackMe. They might have some new rooms that they it's good stuff, but dry better in smaller chunks. Yeah, I might come back to this maybe later. Maybe later. Let's take a look at what stuff they've published over at TryHackMe in the last little bit. It's probably on the dashboard. Okay, so the new rooms are over here. Senior Security Analyst intro. Oh, what is it like to be a Senior Security Analyst? Let's take a look real quick. Explore the duties and exciting operations of a SOC 2 level analyst. This is a job that I don't do. And this is defensive cybersecurity stuff. It might be interesting to see what it's like in the security analyst role. Okay, let's join the room and let's take a quick look. Task 1, Journey to Senior. Ready to take the next step beyond level 1? The natural progression is to the SOC level 2 analyst role. Okay, here's the link for anybody who wants to take a look as well. Where juniors grow into experienced decision-making team members. This room serves as a roadmap for getting there. I'm sorry. The technical skills, the broader toolkit, and the new challenges and responsibilities to expect. You'll also learn how to develop a senior mindset and prepare for more advanced roles. Let's get started. Today you will learn how middle senior responsibilities differ from junior ones, which skills you'd need, and how to prepare for promotion. What a typical day in a SOC Level 2 analyst looks like. Let's get started. Let me Google that.com, thank you. Okay, so what's going on here? So let's see. New role, new duties. SOC Level 2 definition. The Level 2 analyst is a natural progression from the Level 1, a middle or senior level technical role responsible for investigating escalated alerts and responding to threats. As Level 2, you're expected to excel at log analysis and take over basic engineering and incident response tasks. In addition, you should have strong soft skills to mentor juniors, take initiative, and properly communicate with different teams. So we got Level 1 analysts versus Level 2 analysts. What do we got? So it looks like these are numbers that go up, or are these percentages? So 80% log analysis, 30% engineering, no defer, no digital forensics. So communication doesn't have to be as good, initiative also doesn't need to be as good, and they don't do any mentorship. So it looks like Level 1 analysts are mostly doing log analysis and some amount of engineering. Level 2 analysts are doing a lot of log analysis, or they should be good at doing log analysis. They should be better at doing engineering tasks, and they should be better at doing digital forensics, but it doesn't look like they're doing a lot of it. Okay, communication, they should be better at communicating. They should be better at taking initiative, and they should be better at mentorship or directing and answering questions from junior members. Okay, your schedule will typically be split between shift-based triage of escalated alerts, your core duty, and a range of supportive tasks. You'll cover Level 2 triage in the next room, but the supportive side of the role can be quite broad. Unless your company has a dedicated Level 3 position, and D4 team, you may take on lots of senior duties as a level 2. For example, build new detection rules and run threat hunting exercises. Cooperate with the IT team to configure the network securely. Respond to infections, clean malware, and rotate credentials. Participate in or even lead IR in the case of major intrusion. And of course, triage complex alerts escalated by level 1. Importance of soft skills. The biggest difference between level 1 and level 2 is not technical knowledge, but in the soft skills, responsibility, attitude, and mindset. You will need to mentor juniors and help them grow alongside you, take initiative and lead discussions, communicate effectively within the team and externally, and much more. In the next few rooms, you'll learn more about the teamwork and mentorship aspects of the L2. So let's see, should you improve tech, soft, or both skills to become L2? So L2 is both. Okay. Task 3, the fun of being SOC level 2. We've talked about the duties of level 2, but what about the benefits? Beyond the higher salary, you'll have a chance to broaden your worldview and grow in different areas. Mentorship and leadership, closer cooperation with management, incident handling, engineering tasks, and much more. The role should push you out of your comfort zone and stop you from becoming a narrow specialist, incapable of doing anything beyond your favorite task. So we've got few skills and many skills, and then shallow expertise and deep expertise. So I guess what you need to do is you need to know a lot of skills and have deep expertise to be a good level 2 incident response person. Okay? Incident handling. You'll deal with the most interesting cases, attacks that are too complex for level 1s to investigate, info stealers that bypass prevention, supply chain attacks, insider threats, Active Directory intrusions, and so on. You'll also move beyond SIM-only triage and start doing on-host investigations, network and malware analysis, and even some OSINT. There, you'll learn how to respond to attacks using EDR or a regular CLI. See the world beyond SIM, host, cloud, and network points of view. Observe the same attacks you read about in threat reports and blogs. Okay, so it says here, as an L2, you'll often handle the incident first and find it in the news only a few days later. Okay? And then engineering tasks. Only large MSSPs can afford fully analytical L2 roles. Most companies merge L2 duties with detection engineering, SIM maintenance, and security automation. That's actually great because the more side tasks you take on, the wider your worldview becomes. The broad experience you'll build here is vital for your growth. Some tasks you can expect. Simulate an attack and build a detection rule to cover it. Dig deeper into how SIMs and EDRs work internally, and automate a routine task to make your team's life easier. Okay, have you ever wondered how most SIM rules work? As an L2, you'll find out. General security tasks. You'll dig deeper into how the company operates and what parts of it are covered by the SOC. Expect more opportunities to work with IT on patching vulnerabilities, tightening policies, and securing public services. Occasionally, you will help the compliance team analyze pentest results or even run red team exercises yourself. The skills you can build here: learn about corporate processes and the daily life of other departments, especially IT. Discover enterprise software such as SAP, Salesforce, Jira, Stripe, and the M365 suite. Explore new security domains, pen testing, compliance, DevOps, AppSec, and more. By cooperating with IT, you'll better understand how companies are breached. Okay, so does exploring new security areas help you grow? Yay or nay? So the answer has to be yay. Okay, and then I mean, thankfully it's not a super It's not a super long room, so that's good. Sense of responsibility. What a load of nothing. Yeah, maybe we should just turn away right now. Because this seems like, what is the word? Like an advertising campaign. Talking about what all the great things that are going to happen when you move from level 1 to level 2. Anyways, okay, let's move on to something else then. How about we do some CTF exercises from, ooh, what's a good platform to try? HackMyVM.eu. Either HackMyVM.eu or this is another reason I'm getting over TryHackMe. Would like to see more Hack the Box. I would love to cover more Hack the Box. The problem is Hack the Box doesn't have very much stuff that I can upload to my channel, especially because of my what is the word? My preferences. So my preferences are what I upload to HackerFrogs. So free content, evergreen content. I guess it's free and evergreen content. If it's free content but it only lasts for a certain amount of time and you can't access it after a certain period, then I don't want to look at it. Hack the Box content is either free or it is evergreen. It is almost never both. So that's the reason why I don't cover very much Hack the Box content. Grey Wolf Medi says, SOC analyst, step 1, read logs, step 2, something, step 3, profit. I mean, let's take a look at Hack the Box. Maybe we can identify some stuff we can cover. Hack the Box. I wanted to make a period joke, but it passed away. Alright, let's sign into Hack the Box. So I wouldn't say that everything on TryHackMe is bad. It's just that wasn't super useful to me. Verify I'm human. Am I using the wrong account? The wrong password? This is not the password. Let me get my password. Just a second, everybody. Yeah, I mean, the thing is that you expect the good stuff to be stuff that you pay for. Am I actually getting logged in? I can't tell. Okay, I am. Great. Alright, so let's take a look at some of the stuff we could potentially do for Hack the Box. Hack the Box Academy stuff is good. So let's talk about this. Hack the Box Academy materials are very in-depth, and they're very in-depth and they're very well written. But the material is dry. There aren't a lot of hands-on. There aren't a lot of hands-on activities for their academy materials. So that's Hack the Box Academy. Hack the Box Labs. Yeah, we can only do the stuff that is we can only do the stuff that is paid, and my emphasis is not on paid content. Hack the Box Let's Defend, Hack the Box CTF. So Let's Defend, level up your defensive skills. I wonder if they have any evergreen free content over there. I still remember a Kit Kat room from THM that was amazing. It was an OSINT box though. Yeah, there are a lot of good modules. Oh, Let's Defend. Oh, okay, I remember this. Let's Defend is a blue team focused platform. Okay, let's link the accounts. Okay, and then let's take a look at the practice over at Hack the Box. Sorry, Let's Defend. So Let's Defend. We'll take a look at the type of practice they have here. So we're looking for. Let's suppose we want to look for email security. This seems like it could be some fun. Case management, endpoint security. This doesn't seem very easy to navigate though. So log management. So we're looking at basic stuff. So I'm not too sure what exactly this is. Anyways, we'll move away from there. So Let's Defend, CTF, Enterprise Platform. I think there used to be some good like challenges over at Hack the Box. So let's go over to Hack the Box Labs. What is this, a room? I'm not too sure. I'm not too sure what we're looking at. Or a way to find rooms. I thought we were looking at okay, so let's see. We got starting point. So starting point is free. There's a bunch of rooms there that you can. There's a bunch of modules there that you can do, and I've covered these. I've covered these rooms before. I might have to come back to them because I think the last time I published my YouTube videos on these rooms was like 2 years ago, which means I could probably do a better job covering them now. This is some of their evergreen material that is also free. Let me pull these up on my YouTube channel. I just want to check how old these videos are. So yeah, I covered these like 2 years ago. So let's take a look at the other categories over here. So we got starting point, we got machines. The machines are... I would very much like to cover some Hack the Box machines, but it's tough. So we got machines, we got Sherlocks, we got challenges. The challenges are also something that are really nice over at Hack the Box. Let me put this in a new tab. The other thing about Hack the Box is that the challenges from PicoCTF. The problem for me is that PicoCTF is not very popular, and when I upload stuff from PicoCTF to YouTube, nobody watches it. Nobody watches it because nobody's heard of PicoCTF. Everybody's heard of Hack the Box, and everybody's heard of TryHackMe. Okay, but what about these challenges from Hack the Box here? I'm pretty sure the challenges also rotate. They don't. There's no evergreen challenges either. Okay, maybe don't name it EchoCTF in the title, but EchoCTF task or something. Oh, CTF. Name it CTF. Maybe, yeah, maybe. Where was I? I was taking a look at possible platforms to do stuff on. So EchoCTF, there's challenges here, and let's see. Make the fat penguin sing. Okay, so we've got a forensics challenge over here. It's medium difficulty. I wonder if we can do it in 15 minutes. Probably not. The platform is the least important part of the content after all. I mean, it really depends on how you want to do it, but anyways, we're going to be doing this forensics challenge over here as the last thing we're doing. So challenge file uploads make the fat penguin sing .dump.gz. So this is, you know, some good old-fashioned Linux file system forensic stuff. So let's go ahead and take a look. This is a small and easy challenge on forensics with a bit of trickery involved. The idea is simple. You are provided with a dump from a USB device. The USB device was attached on a Linux server during a compromise. The attacker was able to inject malware to the USB device. Find the flags and make the fat penguin sing to prove that cheap tricks don't work on you. Okay, keep in mind that the attacker may have mangled the file system metadata. Okay, what is the Linux file system label? What is the flag? They've got a bunch of questions over here. Okay, so let's go ahead and download the file. I think everybody can get access to this as well. So we'll try downloading this. Okay, and then from here we need to unzip the thing. Oh no, we need to gunzip this thing. So gunzip the thing, and then this is a dump file. Dump file, huh? So if we run file on it, this is a boot sector. Okay, so this is a file system. Typically for file system forensics, I like to use the tools from the sleuth kit. So we can run like MMLS on... Okay, so this is a single file system. We can also run fsstat on the same file. So it says multiple file system types detected, ext2, 3, or fat. I mean, we've been told that this is a fat penguin. So this is a Linux file system on a fat file system. I guess the first thing we need to do is we would run something like file system and we'd run it on make the fat penguin sing.dump. So there's no offset, and the type of file system that is being used is fat. Do we spell it just like this? Hold on. FLS help. And then grep for fat. Okay, let me go ahead and do a little bit of a search. FLS with FAT file system. Okay, so FLS SleuthKit Wiki. Oh, SleuthKit Wiki. SleuthKit Wiki, they've got one, great. Okay, so we'll search for FAT. Oh, there's no... So what are the file system types? FLS command, and we're trying to use the which tab? The -F. So we're told that -F here is -FS type, file system type, FS list for supported types. Okay, so let's go ahead and get that. So we got FAT12, FAT16, FAT32, exFAT. We don't know which FAT file system we're dealing with here. I guess FAT auto detection would work. Okay, so what happened in the input here? We know it's not. We know it's not lean. Okay, so this is VMDK file. So maybe we're using the wrong type of software to interact with this. The fattest of the fat. Okay, if we run this, it says it's a DOS MBR boot sector. FAT 12-bit. Okay, so this is a FAT 12-bit system. So FAT 12. So we would run this with FAT 12, but we can't get anything from the system. VDMK is a virtual machine. You mean why is it why it's file allocation system? Yeah, we're unable to get anything from this, so maybe we're using the wrong software to interact with that. Okay, and hold on. I need to change up my soundtrack. Just a second, everybody. Yeah, so SleuthKit isn't able to get anything from this. Let's go back to the challenge description. Okay, so you're provided with a dump from a USB device. The USB device was attached on a Linux server during a compromise. The attacker was able to inject malware into the USB device. Find the flags and make the fat penguin sing to prove that cheap tricks won't work on you. What is the Linux file system label? Okay, so the dump. So if we just run xxd on this dump file. It's mostly empty. Great. Okay, maybe we can pipe this into less. This is not a bootable disk. Please insert a bootable floppy or press any key to try again. So this is supposed to be a FAT12 file system disk image dump. I wonder which FAT12 is a floppy disk FAT type. A floppy disk FAT type. What is FAT12 file system? FAT12 is a primary used for floppy disks and has a maximum volume of 16 megabytes. FAT16 expanded FAT12's capabilities, supporting larger volume sizes up to 2 gigabytes. So there's a maximum 16 megabytes for this file system, huh? Wondering why I hadn't seen that. And so this is 4 megabytes, so it's under the limit of 16 megabytes. You need to keep up with the OG stuff. Maybe. So what software would be best for... I mean, we could try to mount this, or we could try to reverse the disk image dump and turn it into a mountable disk, maybe? Not too sure what the best way to go about this would be. Because apparently FLS isn't able to make heads nor tails of this thing. Oh no, wait. We do have some stuff. You know what? I think what we might want to do is we might want to extract the file system. I did this in a couple of other challenges. So I think, let me look at my notes. We did this with the Git forensics challenges on PicoCTF. They did list the label. Volume label entry. I mean, we can answer the question right here. That's nice. And thank you for pointing it out, SysOS. Okay, so we answered that question. Question 2, what is the flag of the ETS-CTF file on the Linux file system? I mean, maybe we don't need to dump this all out, but let's try looking at... This was for 2016, I'm pretty sure. So this was forensics. It was forensics Git. And these are the ones where we pulled the file system. We used task recover. So task recover on the file system, and we were able to dump everything into our current directory. Let's try that here. Except this is FAT12. Okay. Oh, we need to change the offset because there's no offset here. We only got one. We only got one file out of it. And the offsets are different. Yeah, there's no offset in this case. Or at least I don't think so. So we managed to... What is this? Oh, okay. Here is something for your troubles etctf. So I mean, we need to delete all of the line breaks. So trd /n. Awesome, you figured out our trick. etctf, I am a trick flag. I am a trick flag. Here's something for your trouble. Sure, we can give this flag here. Okay, here's one of the flags. What is the flag of the etctf file on the Linux file system? Bam. Okay, and the next question is, what is the volume label, the volume name of the non-Linux file system? There is also a volume around here. See if you can find its name to answer the question. There's a non-Linux file system? I mean, they did tell us that there is something different, right? What is the trick flag on the file system? Okay, you know what? We do have the trick flag over here. So we can submit this. Okay, and we got that. What are we missing? What is the flag of the etctf file? What is the flag of the etctf file on the Linux file system? This shouldn't be hard to find, but make sure you don't get carried away. Find the flag and give it its answer, including the etctf prefix. Okay, so we'll keep on working on this for another 15 minutes, and then we'll call it a day. Hopefully, we can get it done in this amount of time. etctf. So what did we actually get from the file system? Let's output this to fls.txt. So we've got, oh, you know what? We've got orphan files over here. We could try. Can we? Oh, there's also an MBR. So there's FAT1, FAT2, and there's MBR. These are different types of, these are different file systems, right? 70-year-old peer. 70-year-old peer. What are we talking about? MBR master boot record. So we got etctf, this is a file, and then we've got the label, volume label entry. I mean, we could try to icat each one of these. So icat 3, icat 4. So when we run icat, all we need to give is the name of the dump file and the inode number. Hold on, what's that? What are these inode numbers? So this is one of them. There's 3, there's 4. Oh, we can't run icat. We need to specify the file system, right? FAT12. Yeah. So that's nothing. This is the etctf flag file. And then we can take a look at, maybe we can take a look at these orphan files. When we ran FLS, didn't we do it recursive? No, we didn't do a recursive. Okay, let's run it recursive. Hold on. So you ran it recursive, and it didn't give us any additional things. We'll try taking a look at these icat nodes. So the orphan files one might have some deleted files. Nope, nothing there. What about these other ones? So there are these other nodes. And we got a bunch of non-printable data. And more non-printable data. mkfs.fat. Cyber Sky Blue, hello, nice to see you here. What is up? Hope you're having a good day. We got ads running on Twitch. I'm just going to take a quick water break, just a second. Okay, so what were the other two questions? What is the flag? What is the actual flag after the trick flag? What is the volume serial number of the non-Linux file system? So we're looking for a serial number. The problem is when we dumped the file system, we weren't really able to get anything. But then again, they said that there were multiple file systems on the disk, right? And when we did MMLS, it didn't find anything. When we ran fsstat, multiple file system types detected. Thank you for resubscribing for 6 months in a row. Wow. Happy 6 months, SysOS Master. Much appreciated. Let's give you a fun video redeem. How about some... how about some all the things? Drink all the booze and hack all the things.
This one's dedicated to all the hackers. Yo.
Okay, so I'm just gonna try asking around for instructions on what we're supposed to do with fsstat if it's got multiple file systems. So let's do it over here. I am doing forensics on a disk file system. Dump. It has multiple file systems, but my sleuth kit fsstat command doesn't work. What can I do? fsstat usually fails here because you're pointing at the wrong layer of the image or at the wrong offset. The fix is to identify the volume layout first with MMLS, and then run fsstat against the correct partition starting with the -O. If the image is split across segments, include all segments and set the image type appropriately. Run MMLS on the whole disk image. Okay, so MMLS didn't work on this disk image. It didn't give us any output. Recurse and look for other partition tables in partitions, DOS only. I mean, we can give this a try. So it's MMLS-R. Still doesn't give us anything. print the rounded length in bytes, verbose output. I mean, making it verbose, does that do anything? Kind of. Okay, so I image type -b dev sector size. So what is the format of the image file? Use I list to list supported file types. Okay, so maybe we should supply the image type. So we do mms-i list. So this is raw. And we've got VMDK. So this is the type that we're dealing with right now, I'm pretty sure. So we run -i VMDK. Error. So we can't open this, huh? What else could this be? Multiple AFF multiple file. The other thing that it could be is this could be considered raw, but nothing comes out if we do it like that. But then again, when we ran the file command, it said it was an so DOS MBR boot sector mkfs.fat. Oh, the serial number is here. Okay, let me go ahead and grab that. We can submit it to the challenge. Okay, that wasn't the valid answer. Unfortunate. What is the Linux file system label? Didn't we submit a label? Oh, this was the non-Linux file system. What is the serial volume number of the non-Linux file system? So answer in hex format. This... Oh, okay. So we just need to get rid of the prefix, I think. Don't forget the endianness, it says. So is it 0000000D4? So it's like echo it out and then rev. That can't be it, could it? Okay, according to the Wikipedia, the serial number ID is 4 bytes and kept in 2 different places on the partition, depending on the version of FAT being used. In FAT 12 and 16, used with floppy disk, the ID begins at the byte offset 02739 in decimal. Okay, and the ID begins. Also, don't forget the endianness. So I mean, if we just byte offset 0x27, we could probably find this if we just do like a hex dump. So the hex offset is what? ID begins at offset 0x27, so 39 in decimal. 0 hex 27. So 27 is here. So 2, 20, 21, 22, 23, 24, 25, 26, 27. So it should be this, but how far? And how many digits are we talking about? So the hex format is 1, 2, 3, 4. We're looking for 4 hex digits. 1, 2, 3, 4, 5, 6, 7. And we're looking for 4 digits. If it's 4 digits, it's got to be something like this. Maybe, I don't know, Rivet. Well, it's not 9-2, it's 2-9. It's like, hold on, we need to type this out manually. So it's 0D, and then it's 0, 0, and then it's 0, 0, and then it's 2-9. Something like this. Nope, still doesn't like that. Yeah, I'm not exactly sure. But, I mean, this is a good learning experience. It'd be good to try to figure out what is exactly going on this, and maybe pick up on some good techniques for doing more disk forensics. Anyways, I gotta get going. Let's see if there are any awesome people that are streaming on InfoSec streams. I'm the only person there, but am I the only person who's streaming on Twitch? Oh no. Am I the only person in the tech scene that's streaming on Twitch? Moohoodles is on. We also have MSEC. I think you would enjoy Moohoodles more. Let's go ahead and pull up her stream. Moohoodles is usually doing some NASA and space-related content. Yeah, okay, she is. She's doing some news stuff. Astrobiology and space news. I think you'll have fun over at her channel. So let's start the raid. Hey, thanks, SysOS Master. Much appreciated. Okay, so when you arrive on our channel, if you give this message, let's see. OS Frog, Hip Hop Hack, OS Frog, I would really appreciate it. Just like this. So before we go, I'd like to remind everybody that we're going to be doing well, after the weekend, we're going to be doing a co-working stream on Tuesday. We're going to be doing regular streams on Wednesdays and on Fridays. And yeah, come on by, hang out, talk about cybersecurity. If you have any questions, I'm happy to answer them. Alright everybody, we're getting ready to raid. Have a great weekend, and we will see you next time. HackerFrogs out in 5, 4, 3, 2, 1. See you next time.